Perfetto. Smuto.
Non lo prendo questo.
Questo è
Ci spinge questo. Ah, rispetto quello.
Se no c'è questo.
Dicevo, dovrebbero prendere il posto qui dove si vede. Mettetevi qui davanti, per favore. Tanto potete fare no. Dopo vi dico perché. Faccio domande si può fare dove avete pare. Si può fare dove avete pare solo se noi possiamo rifarle a te.
Ok. Good.
Vai. L'unico ufficiale dell'evento?
Sì. Good morning. Good morning, everyone, and welcome to this workshop that collect the experiences and results of two Erasmus Plus projects that are Beready and AugmentedWearEDU. Okay, so these projects are getting finished soon. We will finish by the end of May, so this is the time to review everything and to disseminate what we got during this project. And for this reason, we organized this workshop in which we can share our research and our activities within this project. So, okay, the day is organized as in the agenda that we published in the website. So we are already late, okay, as usual, but that's fine. It's normal.
Actually,
I would say.
Next talk is at
40.
Okay.
Okay. So, by the way, the workshop were yes. Is it working? No, but this.
Prova. Okay, now yes.
Okay. Sorry. Okay. See. And okay, the program of the day is this one that is available on the website of the event that we quickly prepared yesterday. By the way, originally we thought to this different session, the morning session for Beready project and the afternoon session for the AugmentedWearEDU project. But to organize all the speakers and have everything, we had to mix a little bit the topics. But I mean, I think it's interesting also to see these different points of view during the whole day. So we have a first session from now to, let's say, 1 p.m., okay? With some presentation. We have some change in the program for the availability of one of the speakers, but I will update you later. And then in the afternoon, we will have a second session from 2:30 p.m. to, the serious part of the conference will finish around 6 p.m., but after we will have a demo session and with drinks. Okay, so I invite you to resist up to the end of the day. Okay, I would like to thank... Faccio io ringraziamenti. Ok.
Poi ti introduco, va.
I would like to thank some people. Of course, the European Commission for giving us the money for doing this project and also this event, and also the department, the director, Professor Vignoli, that hosted us, all the technical people that assisted us in setting everything, so the connection, all the organization, and also the colleagues that allowed us to have this nice room for the physical session. And other.
No, I just.
Okay.
Okay. I don't know why these keep muting. Maybe we are talking too much already. No, I would like just to spend a few words to say why we decided to have this joint meeting. Actually, we prepared these two projects so without knowing each other project, but it came out that both are related to augmented reality and virtual reality, and also haptics as a new tool for STEM in education. And the nice thing is that the project that Monica is coordinating as a unit in Siena deals with high school mostly, while the project that we have with colleagues in Norway, and I mean, then you will see the consortium that deals with exams and projects for the university. So we have already these two. We have already these two parts, and the nice thing is that then talking with colleagues organizing this event, it came out that there are another project where there are colleagues involved, and we will have Elena Pessot in the afternoon. And this project is related to augmented and virtual reality for industry. So they are studying a way to use this new technology to teach people how to use novel machines. So we will cover these three aspects during the day. And I mean, it is since there are many projects that the EU community decided to promote on this topic, we think that is really interesting to have them together. Okay, so it seems that this one is not working very well, but I mean, we can use this. So now the first talk is about the Beready project, and it will be Professor Monica Malvezzi.
Okay.
Okay.
Let me find the presentation. Should be. Just a moment. I have to this. Okay. Okay, so I will introduce briefly the objective and the result of Beready. This is a project that it's a multidisciplinary project that was born during the COVID-19 pandemic as an idea for supporting teachers from the high schools in continuing their teaching activities. Okay, so the base of this project is the need that came out from the emergency during the pandemic to have some tools supporting the teachers that were not at the time prepared to overcome the difficulties of an online and distance learning. And okay, this project was born with the idea of preparing resources and good practices to provide some guidelines for the teachers to continue their teaching activities during when the standard teaching is not possible. Okay, the partners of this project are from four countries, Poland, Italy with us, Greece, and Portugal. There were either universities and companies and some high schools that tested our methodologies in their courses. Okay, practically the project can be divided in three main objectives. One is a collection, a survey on the available resources that teachers can use to teach their courses. The second one is the preparation of online courses that were prepared by ourselves and provided to the schools that participated to the project. And the third part is about how the school used these resources for their own activities. Regarding this last point, we will have later on an example directly from a school. We will have a talk with a teacher of an institute that is on the Apennine Mountains, and during a lecture, so also her students will participate to this lecture. Okay, the structure of these three objectives is this one. Firstly, we collected the available tools. Then we used these tools to develop courses, and we try it within the project. And then these methodologies were used for other courses that were given by the teachers themselves. Okay, regarding the first objective, the main outcome of this is an ebook that is the summary of the experiences and examples, tools that we found that can be used for supporting teachers in their teaching activities. Okay, here there is the table of content of the book. It starts with the general methodology that we use for preparing these courses. Then there is a collection of available tools that can be easily accessed by teachers. Then there are some scenarios and some examples of best practices that can be an inspiration for preparing the courses. Okay, regarding the second, so once we had this collection of resources that we could use, then in the second objective we prepared for courses, online courses, one in physics, one in engineering, one in mathematics, and one in technology. Of course, our research unit was involved in the engineering course because of our background, of course. So I will tell you briefly how we organized, together with the other partners of the project, how we organized this course, its structure, and how it can be adapted to different needs. Okay, I think that I see in the audience some of my old students, so they probably will recognize this diagram because it's the same structure that I use in the course of digital modeling that I have here at the Department of Information Engineering and Science here in Siena. So the course has the objective to show to the attendees the whole design process, in particular mechanical design process, starting from the idea up to the physical realization of the prototype. Okay, this is a process that traditionally would be very, very difficult in my experience as a student. I covered all these tasks in very different courses, not very related each other, because at the time there were not so many available resources that could be easily accessed to do all these things. Nowadays, we have the possibility of access to very open resources that allows to see in a course that has a limited, let's say, amount of time to see all these steps. Okay, sorry for the for the small points of this slide. This is the organization of the course that I gave online. It was a course that had that lasted 1 month, more or less, with a synchronous lecture per week of about 2 hours. And in parallel, I assigned some homeworks and videos to see for at least, let's say, 12 hours. So the whole course is about 20 hours. And this is about the whole design process of a mechanical component. Okay, regarding the tools that I use, probably you know all of them because now they are very, very common. So the tools provided by Google platform, so Google Meet for the lectures and group activities, Google Classroom for organizing everything to have all the material available, Google Form for the surveys, for the tests, for the questionnaires, etc. About the tool for modeling, for realizing the design, in this course I decided to use Tinkercad because of the limited amount of time that I had and of the very heterogeneous background of the attendees, so that I could not use a very specialized tool in this type of course. And also I suggested some repositories, some websites that they could use for finding some inspiration and something that could help them in realizing their project. Okay, the course was project-based, so in every lecture there was a part in which I told them let's say, the background that they needed to realize the things. For example, what is a CAD? How can I 3D print an object? Which material should I use, etc. Then there was a part of the lecture in which we worked on projects that were suggested by the students. Okay, they were teachers, but in that role, they were students. Here I reported some of different stages of some of the projects that the students realized. This is the project that was realized by the team in Poland. They sketched a meteorological station with some sensors, so they had to think how to connect and where to put the sensors and things like that. This is an intermediate state of the project by the Italy school. They had an educational robot and they wanted to modify an arm to allow it to do some specific tasks. And this is the preliminary, let's say, design phase from the school from Portugal. They wanted to start designing a little drone, so they find out some components, their dimension, weight, and things like that. Okay, as I said, this course allowed me and the students to follow the whole design process in a very short time. So I think that it would be a nice introduction to this type of problem. Of course, each of the steps need a lot of work, but at least with this short course, they had the possibility to see which are the main problems related to the mechanical design process. In this slide, I reported an example from another team that is the team from Greece. They had the possibility, here you see the evolution of the project starting from the first preliminary ideas and sketches. Then they worked on how to prototype them, and they realized the prototypes and revised them by means of tests. So even if the course was very short, they had the possibility to start from the idea to the physical realization of their idea. This was the design of a hook, for example. About this course, I would say, looking it as a whole course, the main characteristics is that it is project-based, so the attendees start from the first lecture to think to their project. It is modular because each of the bricks that compose the course is something that could be considered independently. Let's say it can be adaptable to different targets. For example, if the course should be was adapted, for example, for a set of students that already have some technical background, one could use a more specialistic tools like SolidWorks, for example. And it is also adaptable in terms of resources. For example, we have a direct experience because with the same, let's say, structure, we had this very short and compact course, but also the course that we have here at the university that is around with Mihai, with the help of Mihai, that is around 60 hours. So it is something that we can adapt to different things. The idea here is that we could even more extend this structure, for example, including even different tests, different courses. Okay, this ends more or less my presentation because this is the activity in which I was more directly involved, the design of the intermediate course. Of course, after this, we had another activity that was the courses that the teachers gave to their students. About this, as I anticipated, we will have another presentation later. Okay, so this more or less ends my presentation. I reported here also the evolution in terms of meetings about this project. We're starting in the very hard pandemic period with online meeting. We had the first two objectives completely online without meet each other, never. Then finally, in the last part of the project, we had the possibility to work together directly in our university. These are two photos from the meeting that we had in Portugal last year. So this is a session in which we worked in group in designing the final courses, and this is a picture that we had after the lecture. And the last one is from the conference that we have 2 weeks ago in Poland, in which we met once again together to have our experience, to tell us our experience about this project. Okay, so I think that I said more or less everything about this project. So if you have questions or something that I would answer.
Don't be shy, eh? We are in a family, let's say. Although there are a lot of people following also online, so let's say a larger family.
Yes, with the spirit of this project, this event is both in here in present with also the coffee break, etc. That is still only physical up to now, but we are working on this. We are working on this, but there is also the possibility to follow the event online, so there is also some attendees online. Okay.
Okay, so thank you, Monica, for this first. Okay. Where is the video?
Here.
Okay, then I will put. Okay, so welcome again. And the coordinator of our project, that is, the name of the project is AugmentedWearEDU. It's a very long name that anyway catches well the idea of having also possible physical interaction in the course. So I would like to spend, so Sanfilippo, that is the coordinator of the project, couldn't join physically because we will have a main event in Timisoara next week. This year, Timisoara is the capital, the European capital of culture, and it will be a week dedicated to VR and AR in education. And we will have a big show there next week. So most of the people of our project is there or is going there. I will go next Monday. And so, but by the way, he sent us a video where he will introduce the project. I would like to spend a few minutes saying a couple of things of the spirit, how this project started, and also on how this Erasmus Plus financement are more or less structured. So the spirit was this. The call ended in March, and we were all at home in the very first phase of the pandemics. So we had the time, let's say, to search for new ideas. And actually, I think that this was my project and the project of Monica were the first two financed Erasmus Plus project in this department. There were a few others in other departments, but was nothing related to engineering. Actually, the interest arose, as you may know, because we wanted really to give an answer to the pandemic. And we started thinking to which could be, so we were already familiar now with the online meeting. not to the level that we are now, but still we were starting, no, already to have Google Meet, Skype, and whatever. And the idea that we had discussing with Filippo was that so the courses, especially at the university, it was not so difficult. I mean, if we think that at least in engineering we are already familiar with internet and all the tools that we had already there, no? But there are many courses at engineering. There are a lot where we have labs, and the labs is something that is super hard to remotize. So we can easily give a frontal lecture on I don't know, mathematics. I don't know. It's not the same feeling to do this in the class or physically or online, but still we can have something that is really close. But when we have physical experiences, especially in labs, it's really complicated to have the same effect on students. And then we said that, of course, if we want to improve the experience in e-learning in labs or in all the courses and all the topics where it's really important to physically interact, maybe we had to think also to new tools like haptics, like haptic interfaces. So the idea was to study a way to make these tools available for students, because of course I cannot ask to students to buy a 20k euros haptic interface to interact with the model. No, it's not possible. So actually, we had here in Siena the experience of other European projects where we were developing interfaces for haptic interaction with the virtual reality. So we took this experience and we tried to make something that can be really affordable for everyone. The idea is to have the possibility to build courses using the material that we provide online. So you will see, I think that then Filippo will present this in the video. But the final goal is to have a website where you have all the tools to design courses that also consider the possibility to interact with something with haptic interface. Interact with what? Could be models, could be physical experience that someone is doing. So the teacher maybe is touching something and the people at home can perceive what the teacher is touching, but you will see some examples in the next. And okay, so let me start with the video, the coordinator Filippo, and then I think he will introduce all the partners. Sì, la sua pagina. No, no, no. Okay. So, Filippo was introducing. I would like just to add, if you have question on the work of Filippo, then I can try to answer. Although, I mean, this first part of the work was mostly on the visual and the auditory part, and we are integrating our haptic interfaces in their handle of the HTC system. I would like just to show one part that may be interesting, that is in the website of AugmentedWearEDU. Okay, which is the part related to e-learning. Okay, so we together with the website, this one where you will find the way to download the CAD models and everything to build yourself the haptic interfaces. There are also courses that that are free online, and so they are related to. There is an introduction on immersive technology, and there are videos on VR devices, ER devices, to haptics, and also on examples of merging of the three. And the idea is that people, and especially also teachers that want to design courses, can go there and start with this very low-level introduction to the topic. And I would like to thank Giovanni, Bernardo, and Michele, and Leonardo that helped me in designing this course in Haptics here. And basically it's all available online, and it's really an entry level for people that would like to start. Okay, so we can move to the next speaker. Actually, in the original program, there was a colleague from Greece of Edumotiva presenting the work of their company, but then we are outside of the world pandemic, but still he got the COVID. So we found in our family a very nice way to substitute it, because we will spend the next half an hour in seeing a very advanced application of what we are saying, in my opinion, because we will see how this mixture of reality and virtual and real can reach also the level where people that are online can physically interact with in a place remotely. So who is coming? Bernardo. So this is the idea of the physical metaverse, and now Bernardo and Giovanni will show us. What you can place the. Metto qui. No. Dov'è? Ok. No.
Là.
Qui.
Ok. Se si potesse. Ok, se non lascia stare.
Vabbè. Vai.
Okay, so thank you, Gionata. I'm Bernardo Grogi from the... Perché parte?
Che hai messo il
Lascia una seconda.
O parte la seconda?
Se vai su presentazioni probabilmente c'hai un timing.
No, così.
C'hai automatico. Metti. No, sto scherzando. Non mi ricordo.
Questo devo... No.
Insomma, frega. Coglioni dietro.
Sembra pare forse.
Ok.
So, I'm Bernardo Brogi from the SIRS Lab Siena Robotics and System Lab of the University of Siena, and I'm going to present together with my colleague Giovanni our research and our work about the physical metaverse. So, as the name suggests, we are talking about metaverse. So metaverse is as you may know, is a three-dimensional virtual world in which user can interact with each other through their avatars. But however, in the metaverse, there is a lack of manipulation capabilities because, for instance, imagine a scenario where a user wants to pour water for a long-distance friend. This is not possible in the current implementation of the metaverse because avatars are not able to grasp or manipulate a real object in physical environments. So for that reason, we developed a physical version of the metaverse that we named physical metaverse. and thanks with the new interface that we call Avatar, we are able to manipulate also remote physical objects thanks to this interface. So an avatar is a real avatar, and with that is able to manipulate physical remote object, exploiting a robotic arm placed on a remote site. And then this robot, of course, is hidden from view on the head-mounted display that the user wears, and replaced by its virtual avatar. So, as is depicted in this picture, there are 4 different parts. In particular, we have the upper part, in which we see the augmented scene with the robot, which is remote from both the point of view of user A and user B, that in this case is the avatar of the scene. And then in the lower part, we have the real scene, and so we see the robot that is computing the action that resemble the action computed by the avatar. So, as I said before, we have in particular 3 fundamental building blocks about the physical metaverse. In particular, the first one is about hiding the robot from the view, and the replacement of a virtual avatar in the video stream that the user can see through the head-mounted display. Then the second one is about the control of the robot that needs to pair the movements of the avatar. And finally, in order to improve the realism and the immersivity of the scene, we equip the robot and the effector with force sensor in order to let the avatar perceive the interaction through an haptic interface. So, first of all, I would like to talk you something about the robot canceling method, which is the first fundamental building block of this work. And in particular, differently from the previously state of art of robot cancellation, we use the information about the 3D CAD model of the robot that is moving accordingly to the real robot kinematics. And in particular, the procedure is the following, and the one depicted in the figure. So, first of all, picture about the environment background without the robot is taken. And then, thanks to a suitable developed 3D world with a virtual camera, we record the CAD model of the robot while it is moving in front of a black panel. And thanks to the segmentation and binarization algorithm of the stream of the record, is it possible to generate a binary mask. So this binary mask contains the information about the position of the robot that is seen from the camera, and in particular is very crucial because it contains the information about the part to extract of the background in order to get the illusion of transparency. And in particular, with the binary mask and the composition of the background, it is possible to obtain the chromatic mask, which is the binary mask but colored. And then, with the superimposition of the chromatic mask with the streaming video that we reckon from the camera, is it possible to get the cancellation and then the illusion of transparency. Okay.
And concerning instead the robot motion control, we didn't decide to pair the movements of the robot with the one of the hand, because our purpose was to pair the movements of physical and virtual objects. So, of course, both grasping theory and homogeneous transformations were exploited in order to make the movements of the digital object overlap the one instead of the real one. So, After this, of course, what we have to pair was the gripper of the robot with the hand of the human. And in order to do this, so again, the distance between the fingers of the real hand, which are tracked, were mapped onto the parallel jaw gripper of the robot. Moreover, in order to aware the user of the condition of the robot, we also exploited a manipulability measure of the robot in order to aware the user with a vibration feedback of the position of the robot, because of course, whenever the robot was near to a singular position, then the user was aware that the movement could not have been performed by the robot. The third building block was instead the force feedback, because of course, as we know, in a virtual reality scenario, you want to have also a tactile or haptic feedback in order to be able to understand better what you are holding and how. So we exploited the WeArt thimbles. And as I was saying before, of course, the gripper amplitude was mapped from the fingers to the gripper. And then the ATI sensors were exploited in order to feedback the force which was sensed by the robot to the human, such that he knew if the real object was grasped and, of course, how the grasp was strong, how much the grasp was strong. An evaluation of this, of all these methods was needed in order to assess the feasibility and, of course, if how the method was performing. And first of all, we decided to see how the robot cancellation was performing. And this was done by computing the number of pixels of the robot which were appearing on the scene, because of course this was a measure of how much the cancellation was good. Then, of course, experiments were also done on the accuracy of the robot motion, that is how large was the error between end effector and between the real object and the digital object. And finally, we also investigate the sense of presence and co-presence of the users, because that's the real purpose of the physical metaverse, to feel like you are together, even if you are physically remote. So this is the first experiment. So as we can see, as I was saying, the first one shows, for instance, a pixel which is appearing, which is something that we wanted to minimize. Then in the second one, we can see the comparison between the trajectory of the real bottle and the digital one. And as we can see, this is pretty good. I mean, we cannot really see the difference here in this. This was a Turing task, so just a representative trial, but of course, we repeated the experiments many times. Here instead, we also did an experiment on the haptic feedback. That is, we performed an experiment of making a cube enter inside a cup, and this was repeated many times, randomly choosing if the haptic feedback was present or not. And indeed, what resulted was that the success of this race and the velocity in which this was performed was better when the haptic feedback was given. And finally, we can see a representative scenario of the experiment which was performed in order to assess the sense of co-presence and presence between two users. In particular, the two users were asked to collaborate in order to put the little cup inside the big one. So here is the video. And in particular, we have that in the one on the top, the robot is hidden, as we can see. While instead, on the bottom, the robot is present. So we can see that the cancellation performs really well. And of course, it's much more realistic. And here is how the object falls inside the cup. Thank you.
Okay, thank you. So, I think that this work is really nice, and if we think to the potentials related to possible e-learning, no, because Of course, with haptic interfaces at home, we can for sure perceive so what the teacher is doing. No, but if we really want to interact in the labs, we need also to move something. So what we are studying here, I think, is really interesting. And yeah, we have no time for this. Yeah. This take me the opportunity to remember actually Vincent Hayward, that unfortunately recently passed away. And one of the first meeting, he was removing, like you, the USB, and he said, "Life is too short to wait for the USB." So remove it. And okay, so the next speaker is again Monica, but with a yeah. We promise is the last one. So you have the slides here? Okay. So the talk will be on tools for e-learning in robotics, right? Okay, so you can use this.
Okay. Okay. So, okay, the title of this talk is Accessible Educational Resources for Teaching and Learning Robotics. And this is an activity that we carried out in another European project that was INBOTS. INBOTS is acronym of Inclusive Robotics for a Better Society. And it was also a very multidisciplinary project in which we analyzed the role and of robots in when they come close to the humans from different and multidisciplinary points of view. This is the first time that we had the possibility to interact with Edumotiva, that is the company where Dimitris Alimisis, that was planned for the previous speech, but was not possible to have here for some problems. And if I don't know if he's following us by YouTube, in case I greet him. By the way, okay. In this project, we had the possibility to analyze the role of robots in the society from different points of view, from the points of view of companies, from the points of view of the academia, from the technological and technical point of view, but also from the more human, let's say, point of view. And in particular, among the different aspects that we analyzed in this project, we were in charge of dealing with the educational aspect. Why? Because if the robots are, let's say, constrained in an industrial rigid setup as they did until a few years ago, of course, the first aspect that we have to see is the performance aspect. We want to have robots that are as performant as possible, as quick as possible, as strong as possible. But once robots exit from this rigid framework and works with humans, there are other aspects that should be considered. There are aspects related to the safety, but also aspects related to the psychological point of view, physical point of view. And therefore, we have to consider not only technological aspect, but also human-related aspect. And yes, we as engineers are working in developing new, innovative, new, powerful and nice robotic devices, but are we sure that such devices will be accepted by the society, will be assumed as a collaborator, as a support in our everyday life? Okay, so there is a new chapter in the robotic history up to now, that is the human-centered robotics part, in which the human is at the center of robotics development. And okay, so to do this, we have to bring together very different, usually not well related knowledges. For example, engineers with people that deals with ethical aspects, psychological, medical aspect also. So there is also the need to build a common language so that all these people can talk together to get the right device for each need that we have. And this poses new challenges also to the educational framework, because we have to, people has to learn about what a robot is, how it works, how is it composed, and so on. Of course, we as engineers, in the audience I see mostly engineers, are used to study the robot from the physical, electromechanical point of view. We probably have studied what a robot is on the Professor Siciliano book, so the Navitartenberg, dynamics, kinematics, control, and so on and so forth. But this is not only enough for knowing how a robot behaves with the human. So we have to complete this, and again, we have to find, and if there are, or in case this is not possible, to develop resources for training people to interact with robots, even if they have not a possibility to develop them from the technological point of view, but they should know at least how a robot works, what it can do, what it cannot do, so not to have too high or too low expectations, for example. So again, what we did in this project was to find and organize the accessible and available resources for learning and teaching also robotics from not only the technological and engineering point of view. Okay, so in this work, I could say that is related to the first step. This is a project that came before the Beready project, and this could be a chapter, let's say, of the first step of Beready, in which we review and organize somehow the resources that are available for robotic training and education. Okay. Yes, depending on the background and objective of that each subject has, we have the need of approaching robotics from different points of view. In INBOTS, we try to find a roadmap to guide the learner towards these available resources. So we could need tools for understanding the basic and advanced concept through structured courses, but we could need also to find some resources for inspiration by means of brief talks or videos or tutorials that are more accessible without the need of following a something that is more structured. And also, in some cases, we also need to know what works with the practical activities. And yes, so the objective of these activities was to provide a map for orienting somehow a learner in learning robotics tools. And to do this, we made a research, and we tried to organize the resources that we found according to different criteria. The first one was to classify these resources in these three groups that are, the first one is something that, let's say, is the virtual extension of what we do in our courses. So they are resources that need to be accessed in a sequential way. So look at the lecture, do the exercise, review, lecture, review, etc. There are resources that can be accessed in a random way, so you can get the subject that you need with a tool, a resource that is self-contained, let's say. And then we collected a set of resources to have hands-on activities. Here we listed all the resources that we found, and we found this type of resources. For each resource, we identify if the access is sequential or, let's say, random or customizable, let's say. If the type of content, if it's something that is a video, something, a recording, etc. If this resource provides you credits or certification, the overall level of the resource, so if it's general or if it needs some specialistic knowledge, and finally, if it's free or you need to pay for this. The resources that we decided to classify are the massive online courses, lecture series, YouTube channels, podcasts, and also other types of resources like TED Talks and tools for hands-on activity. Okay, here you can see how we classified all things. Yes, regarding massive online course, typically they have a free access. You can access to the lecture, but you need to pay when you want to get a certification, an official document that assesses that you are following that course. Okay, yes, what is a massive online course? Yeah, after these years, this is something that is very common right now. Massive open online course, so they are resources that collect different types of tools in a structured way that a student can access. They have a structured, a fixed structure, but it can be accessed with typically with the time that the learner choose for that. Of course, the trend of massive online course over the last year is very clear. Here you see a continuous increase. In this diagram, I reported the number of available courses over the last year. You see that the growth is rather continuous. The interesting thing is about the number of attendees of these courses that in the last few years had a non-linear and very higher increase due probably to the effect of pandemic and the need of having tools for online training and learning. Here there are some numbers about the number of available courses, the number of universities involved in this, in the development of these resources, how many students, how many courses. Some courses are organized in a coordinated way, so to get also a more complete certification, etc. Okay. Regarding, the previous slide was relative to massive online courses in general. Regarding courses that are provided on robotics, we analyzed a lot of them actually, and we tried to identify which are the possible target. And of course, the majority of them are courses developed for the university students, but there is an increasing, so university classically engineering courses, let's say, but there is an increasing trend in developing resources also for other contexts, like for example for schools, but also courses on social robotics, so robots that are supposed to work very closely to humans, and also courses for professional training. Other than, sorry. Okay, beside the massive online courses, we also collected a set of resources that are lecture series. This is something that is slightly less structured than MOOC, because these are basically a collection of videos that professors and teachers provided to their audience, and they recorded their lectures and they made them available through YouTube or other channels. So this is something that is not strictly developed with a massive online course methodology, but is still a set of resources that are useful for learners, and that have a structured form, because they are the virtual course that the professor gave in their courses. I mentioned here, for example, the course by Professor Khatib or the course by Professor De Luca, that are quite famous and also used by us as a learner, and also for our courses as a integration support. An example that we, in this context, is something that actually we developed also here in this department, is a course on grasping, or on robotic grasping and manipulation, coordinated by Professor Pratikits, on which also Maria Pozzi and I participated, recording some of the lectures. Probably some of you already know these lectures. Other courses that could be considered in this framework are this one. Okay, putting together all the structured resources, massive online courses and lecture series, we could identify these families, let's say. So courses related to robotic foundations, more advanced robotic courses, courses that allows you to build and program your own robot, and there are also some courses that are related to the societal and non-technical impact of robotics. Okay, there are also resources that are not structured in a sequential way, so that you can access them directly without a specific order. Among them, we, for example, identified one of the most relevant is represented by YouTube videos. Of course, it's not possible to have a map of all the videos that are available on YouTube regarding robots, because it's a huge work to do, but we identified and we tried to analyze and to classify the main channels, thematic channels dealing with robotics. Okay, here there is the distribution. We used it's difficult to evaluate and compare among them the quality and the contents of such heterogeneous type of resources. The only objective data that we could use is the number of subscribers. So we use this with this way to have a first classification of these type of resources. And furthermore, we divided this thematic channel between channels provided directly by robotic companies like ABB and so on, and channels developed by let's say private subject developed for education or also entertainment purposes. And it's interesting to see that among the more common, more famous thematic channels, there are these ones that are developed, specified for education and entertainment purposes. This is something that could be interesting to consider also. Okay. Yes, here I just listed the consideration that we already did, the division between the classification between companies and entertainment channels, and or how they are distributed over the YouTube. Another resource that we decided to consider, even if this is really less technical because of the way we can afford this type of resources, is represented by podcast. This is a tool that is used for information mainly, but there are studies, there are also applications in which this type of resource is used for learning. And it's interesting, because with this type of resource, we have the possibility also to listen discussion, and this is particularly interesting for less technical and more society-related aspect of robotics. So, we are aware of the discussion about artificial intelligence and its role in the society. Also, there is an impact due to robotics in the society, and through this type of a resource, there is a discussion in which also a learner can be aware of what's happening around this type of around this world, let's say. Okay, also regarding the podcast related to robotics, here we reviewed a lot of them, and we realized that there is a great interest and an increasing trend in this type of resource. So this is something that is interesting to notice. Okay, I was very quick. This work actually contained a lot of other aspects that should be consider, we collected this in a work that you could analyze more in details in this paper that you can get from this link. Otherwise, you can just ask me. I will send you if you don't. Yes. Okay. So, okay, as a summary, yes, of course, we have a lot of, nowadays we have a lot of accessible and open resources to learn. So it's also difficult to orient among these wide set of possible resources. In this work, we try to classify and to see what is available and how this could be used in a learning framework. And of course, this is just an image of the state of the art of a very dynamic world. So this is something that is continuously evolving. With this, I could close my presentation. Other questions from the audience? If not, I welcome. Okay. Eccoli. So I welcome Anna Maria Lisotti and their classroom. First of all, how are you? How is?
Hello.
Hello.
It is our turn.
Yes.
Okay.
If you want, we are slightly early. We were late, but we recovered. So welcome to you. And
Niente questo, ma vabbè, ma penso che good morning, everyone. Just 1 minute because our presentation will be made in this way. The students will present the practical part of the free printing models, and then I will recap what all the project was about. But first, we will give the field to them. So they need just 1 moment, and they will present themselves.
mm-hmm.
Can we share our screen?
Yes, okay. Thank you.
Allora,
So.
venite qua voi. Poi se avete bisogno alziamo magari il volume. Ok, certo, io vado via, adesso mi metto lì davanti e qua siete voi.
Good morning to everyone.
So, Anna Maria, just one quick question. About the situation. Are you safe? Everything is fine? We know about the weather.
Yes, no worry. Fortunately, this area is safe.
Okay.
We are in an altitude higher than the place that took the damage. So don't worry for us.
Thank you. Okay.
So good morning. I'm Fra Reattore, and okay. So do you see the presentation? But I think that you see it. I'm sorry. Can you see the presentation? So
Yes, we can.
Okay, perfect. And good morning. I'm Fra Reattore, and welcome to our 3D project. We are the students of Cavazzi Sorbelli School, and we are very glad and proud of our project, and we will introduce you what we did in the past weeks. because this project was really special for us. That obviously took us many weeks, but I think that we all enjoyed each of them. So I wanted also to start the presentation with the photo of our class. I'm the guy here. And these are the faces that took the end on the programs and on the models that you were able to touch and see. Also, I want to talk about to what I'm going to talk. I created.
Excuse me, is there any microphone?
Say again, we didn't catch the question.
Is any microphone open because there is
Microphone.
some reverb.
I can mute mine.
Okay, but I think that you can listen pretty well, right? So. Okay. So going ahead, we created this index for you to let you visualize and understand better what we are going to talk about. In fact, I started with the intro and then who we are. Then we will proceed with the purposes, so what made us start the project. Then afterwards, we will let you see the age pyramids and the program that we used, so GeoGebra, but no worry if now maybe you don't understand something, because we will explain everything later. And in the end, we will explain to you some these two simple methods to create the models with that we used, and maybe I hope that in the end you will be able to create your own. Maybe also if you have a stamp, a 3D printer. So I wanted also to analyze another important point. So how we worked. Obviously, the first thing that you need is a computer, but don't worry if you don't have the NASA's computer, because we saw in class that with a common computer you can work pretty well. Obviously, the computer needs to support the programs, but I think that it will not be a problem. And also, I mentioned new skills and the new programs. New skills because for the most of us, these new programs were new for us. So we also had to apprend new skills by the new programs, but with the help of our teacher and internet, we manage pretty well the stuff. And another important point was obviously the collaboration, because with it we were able to speed up the process. So this is surely another really important point. And in the end, you will just need a 3D printer for bring to the life your model.
Hello, I'm Isabel, and before moving on to the programs, I wanted to tell you about the roots of our idea, so what we wanted to achieve with our work. And we have three main purposes that you see here on the presentation. The first one is better understanding. So it means that we didn't want to have to face different documents, long data documents, for example, on Excel, they are full of numbers and not everyone can understand them. So with our 3D models, everyone is able to understand in a new and better way the data or the information because you have on hand in real life your 3D models. And also, which is connected to the second point, touch and visualize. Everyone from all ages, so old people and young people, are able to immediately and physically see the object in front of us. So instead of looking at a computer and all the numbers, you are able to see the information on hand in real life and understand it better. And also we have the third point, which is connect or more connection, which means that for all these weeks we collaborated, helped each other throughout the process. And with our help, even though we have individually created our own 3D project, everyone is able not only to recreate the project, but also personalize it. So everyone is able to choose their very own databases or files and then recreate the 3D project so that it's unique for every model.
Hello, I'm Sara Vignodini, and I'm going to introduce you what we have done before all the process that my classmate is going to introduce you after. In particular, I'm talking about the age pyramids, and we decided to duplicate it, inspired by the one that we have seen on internet. And for doing that, we have used GeoGebra. How we have done it. In particular, firstly, we have decided our age pyramids. In this case, we have decided the United Arab Emirates age pyramids. We have uploaded the imaging on GeoGebra and we have worked on it. In particular, we have tracked the shape using the points and putting them in each angle. And after that, through the function spline, we have connected all the points with a line. After that, we have opened the 3D window in which we have seen we can see the model, the 3D model, and with the function surface, we can rotate the model around the epsilon axis. After that, we have uploaded the STL file that we have downloaded through GeoGebra in Campus Print, in which we have modified the project, put it on the right axis, and in particular, we have made it big enough to be seen, but also small enough to be contained by the 3D printer. And we have also built the heat support. After that, we are ready to print, and we have printed, this is an example of a printed age pyramid. And this is very important because, for example, in Italy, we know that the situation of the younger generation, it's not really good because we are very few. And for this reason, we will have to support the older generation. And for this reason, the state, through this model, can understand, and also the big company, which part improve.
Good morning, I'm Elia, and today I'm going to tell you something about our mapping and 3D printing project for cities and countries. These are some examples that we got thanks to this project in class. Okay, before starting to talk about the project, I would like to tell you something about the program that we used and the data that we needed to do this project. We used the QGIS program. It's the main program of this project. Then we used FreeCAD, but you can use every CAD you prefer. It's not important that it has to be FreeCAD. Then we used the Blender and Campus Print. We use Campus Print because our printer supports Campus Print, but you can use the software that you prefer. Then we need the two different type of files, the .csv file and the .geojson file. For the .csv file, it has to be geolocated in space. So in the data have to be the longitude and the latitude. Now there are two ways to work in this project, and I will tell you something about both of them. The first method, the first way to work, I will start from the one with the hexagon. So let's start. First thing, we need to open a new file QGIS, of course, and put the right reference system, because the data, as we said before, are geolocated in space. So we need a reference system, and we can easily, it's different for every country, but we can easily find it on internet searching it. Then we put the .geojson file on QGIS, and we will change the reference system of. Then we have to delete the internal borders. After that, we use the QGIS print composer to export a .svg file of the simplified layer, and we will use it later to create the base for our model. Then we can add our .csv file as a geospatial point, and we can also filter the data if we need to filter them to include only the data that we need. We create also an hexagon grid, and we clip the hexagon grid with the base layer using the intersection tools on QGIS. The last part on QGIS, we have to count the points in each hexagon. To do this, we use the calculation tools that we can find on QGIS. And also, I suggest to add a color gradient, so to understand watching it in which hexagon there are more data. Then we have to export the .shp file from QGIS. Now we change program. We use FreeCAD. We put the .svg file that we got before from QGIS on FreeCAD, and we will extrude it. I suggest to extrude it about 0.05 centimeters, and then we put the .stl file, and then we export the .stl file. We open Blender, and we put on Blender both the STL file that we got from FreeCAD and the SHP file that we got from QGIS, and we overlap them. Then exporting it, we can put it on Campus Print or the software of printing that you prefer, and the model is ready to be printed. As we said before, okay, there is also a second method, a second way how to work. This one is probably easier. The proceeding on QGIS is pretty the same, but we can avoid to delete the internal borders and create the hexagon grid, because we are going to use the internal border as a grid. This is easier because we don't have to create a base for our model, for our data. We can easily export from QGIS the .stl file and put it on Campus Print ready to be printed.
So this was our presentation, but we have also a video that we wanted to show you if we have time. But before that, we wanted to ask you if you have any questions about our presentation.
Okay, yes, we have time if you want to share also the video.
Okay, perfect. So do you still see the presentation?
Yes, thank you.
Okay.
Just a moment that he's charging. Oh. I think that we have a problem with internet, but
Okay.
okay. Just a moment.
While they are trying to see if they can fix this, I will just say a few things, really not much, because I don't think it is the time now. What you have seen is just one small part of what has been done during the Beready project in our school. The topic was statistics, and it was mainly focused on communicating statistics and communicating it as an experience, a multisensorial experience. So we worked also on sonification, on dynamic data art, and you can find all of this, all the teacher's guide, the students, and so on. You can find them. You will find them on the website that surely Monica has shown or will show to you. So if you are interested in this kind of thing, you can find the references, student sheets, tutorials, whatever is needed for teachers and students to work on this kind of thing. Just one moment, did you find it? If otherwise, if you have YouTube, ok. E lo faccio partire da qua? Allora, aspetta un attimo però che devono avere il... Presento. Allora, venite qua. Schermo intero? Finestra?
No, va bene.
Ok. Allora, aspetta che vi faccio fare. Questo?
Sì. Video va?
A me non si sente però.
Can you listen to the audio or...
Okay, it's you can't hear the audio, but I hope you can see the video. And of course, it was about how to have a better experience with data. Okay, so this is all for Italy. Sorry for the missing audio. If there are any questions, yes, we are here.
Okay, so before starting with the questions, I would like to thank you for the presentation. And yes, actually, indirectly, let's say, we found another common point between the main theme of today's conference and what you did, because yes, today we are working and we will see different presentation that deals with haptics. So it's another way that allows you to convey information through the sense of touch. it's interesting what you did, because yes, you made some informations that typically are available only with visual and auditory channel, let's say, with another channel that for sure enrich the whole information and information process. So for sure, I'm happy that you participated to this conference, even in distance mode. I hope able to come here in Siena to show us the real object that you did. Are there questions or comments from us? And
I want also to thank and to say that you did a very great presentations in English. So really,
Thank you.
congratulations for the presentation. It was really interesting, and so what Monica was saying about the possibility to touch data. It's really interesting. You did the hard way, let's say, with really physically printing out that, and maybe haptics could be something that can be added to keep it virtual, but still touch something. So it's really interesting, this idea of touching the data. So keep going on, and yeah, thanks again.
And yes, congratulations to you as students for all the work that you did, and also to Anna Maria and her colleagues for teaching you to do this great project. So bravi, bravi, bravi.
Thanks a lot. Thanks so much.
Okay. So thank you, Anna Maria.
Thank you.
Okay, so we are
Actually, in advance.
in advance. Okay, now we are going to the physical lunch. So, but this is not possible online. Sorry.
The camera.
Okay. Sorry. So we are restarting the afternoon session. Here
Just quickly, I want to say to Silvio that there was a mistake in my mail. So it's the schedule is like the one we are seeing. So it's at 3. I thought you were mentioning the length of the talk. So sorry, it's at 3. See
No
you
problem.
in a
See you
while.
at 3.
Okay.
Yes.
Okay. So it's a very great pleasure with that I introduced this new talk, the first of the afternoon session. It's by Alessandra Romano, that is a colleague, associate professor at the department, let me try to say in English, social, political, and sciences. And she's working on the teaching of STEAM subjects from a point of view that is necessary as the one that we have seen, even more than the one that we have seen this morning, because it's the pedagogical aspect. So I'm very happy to have her here, because it's a way to also to see the different points of view, and also to find ways to collaborate, to find common path, etc. So thank you, Alessandra, for joining this workshop, and I leave you the stage.
Thank you. Can I use that microphone?
Yes.
The other one, this one.
Ah, this. I don't know if it's working or not. Try, but it's not.
Does it
very-
work? Okay, very well. Also, people from the distance, can you hear me? I hope so. So, in the meantime of the lunch, I just uploaded my presentation on this super populated desktop, and yeah. So, welcome everybody. It's a real pleasure for me to stay here with you today, this afternoon, and I want to thank Professor Malvezzi and Professor Salvietti for this much appreciated inviting to me. As mentioned by Professor Malvezzi, I'm an associate professor, but I don't have any kind of engineering background, because I am an associate professor in teaching and learning methods. So I bring the perspective of a pedagogical approach for the STEM teaching. And today, I would like to discuss with you a couple of projects that we have been carrying out as a department so far. And the first one is a project that... share?
Oh, yes. Yeah, you agree.
Sorry.
Oh, maybe we are sharing.
No, this is the program of the conference.
Okay.
Share the screen.
If you share the screen, so
And we are not sharing the screen.
No, we are sharing only this. Okay. So
Okay.
interrompi.
And we will reshare again. I'm sorry.
Exactly. Sorry.
In this case, our screen instead of just a window,
Yes,
right?
right.
Okay. So now you should see everything?
yes.
Okay, perfect.
Thank you.
So that's the best of the being time. Okay. So the first, I was mentioning to you that we are here to present you a couple of projects that we have been carrying out as a department so far. The first one is the project Mind STEM Gap, and is a project about how to overcome gender discriminations when choosing the degree path, the degree courses in higher education about STEM professions. And the second project is an Erasmus Plus funded project that, oh, welcome. Ciao, ben trovato, welcome. So the second project is an Erasmus Plus funded project that is called the Test Technologies for STEM Teaching, and maybe we will have a more centered focus on this project that can be much more interesting also for you. I want to just mention this project, Mind STEM Gap, because it's a regional funded project. I'm not sure why we were funded for this project, because we were Department of Social, Political and Cognitive Science, but it's about how to train, how to educate third and fourth secondary school students for their academic choice. Okay, and it was a project about how to face and overcome gender gap and gender stereotypes in choosing STEM degree courses. I don't know if you noticed this also in your university course, but there still is a gender gap in choosing STEM degree courses, and that's the reason why we have been funded for this project. We organized several laboratories with the students of 12 secondary schools. We invited Professor Malvezzi as one of the women scientists that could model examples of how to overcome gender gap, and we organized each laboratory in a much more proactive way in order to overcome gender stereotypes. What was the aim of this project? The aim of this project that lasted for 4 months was to facilitate the access to the degree courses in STEM of students, both female and male students, and at the same time build a kind of a manifesto for overcoming the gender gap in STEM education. And that's the kind of manifesto for the STEM of gender that the students realize during this laboratory path. This was pretty similar to another project that's the double version of our manifesto for gender STEM, and was pretty similar to this other event that will be hosted in this department tomorrow. So we just discovered this cross-fertilization with this community of women scientists that tomorrow will organize this in this department. This was one of the aspects through which we are working on the topic of STEM education. And so just imagine that the kind of a contribution that we can provide is how we work with the gender stereotypes, inclusive education. The second project that I want to introduce you today is the Erasmus Plaza. Welcome. I apologize, we started in the meantime. Okay, that's fine. And you didn't miss so much, just the presentation of another project. But let's focus on the second one that could be much more interesting also for you. This Erasmus funded project is a
quite similar to the Beready project that was presented this morning. You can see that the test is called the Technologies for STEM Teaching. And you can see the imprinting of the art that was put in the STEM acronym in the kind of visual products that we have realized so far. And this Erasmus funded project lasted for 24 months. It's still in progress. We are in the 16th month of the project, and we are the scientific responsible as University of Siena, but there are other 7 countries involved. This is the scientific team of our university, and what was the aim of this project? It has been a really ambitious project because we were the only educational research unit. Our partners were all from engineering, informatics. Well, most of them were from these 2 sides. And so for us, it was pretty challenging to work in a very cross-disciplinary way, okay? I mentioned it to Professor Malvezzi that I feel like a fish out of the water because you are the expert in this field, but we are here to learn also from the other presentations that will follow in the afternoon. And also to create possibilities for future trajectories of collaboration for sure. The aim of this project, well, actually this project has 3 aims. The first one was to develop a professional development. Did I miss anything? No.
No, I don't know if the microphone is working.
Really? I will change. I apologize for who is. We really care about being inclusive. It's not, but that's a good example of the kind of technological issues that we really, really face in the truth, okay? So we can speak about all the wonderful devices that we can develop, but when we go out of, not when we go out, also when we are in our university, most of the issues are about technical stuff, especially at Durham. I'm not sure that if this happens also here. So I was telling you that the aims of this Erasmus Plus project was to develop a professional learning program for teachers, faculty in higher education. The second aim was to develop 10 open educational resources about the topic of the adaptive teaching in STEM education. And the third aim was to develop a toolkit, a methodological toolkit for the creation of virtual and e-lab. When I read the proposal of the test project, I was like, I have no idea of what we are talking about, but I have learned so much working with the other research unit that help us to develop all the project results that were, that were designed in the proposal. Where we are right now, I told you that it's still in progress, okay? So this is the timeline of this Erasmus Plus project. And if you see, we just started in March 2022. We were 10 research units. We were the only educational unit, and we have been working with colleagues from engineering and informatics, and also with the 3 technical partners. And so far, we have developed the professional development program for teachers and for faculty. We have been developing the 10 open educational resources, and I will show you a short demo about this. We are still now working on the toolkit, this kind of a methodological toolkit that should be useful for faculty and teachers that want to plan and design and realize virtual and e-labs. The problem is that this project has been proposed and submitted during the pandemic. So the kind of interest and the kind of utility of this project was felt as particularly relevant during the pandemic when we were forced to distance learning. Now it can have an impact, but we should recognize that the project has been planned in another time. Where we are. So first, we conducted an action research process. So we started from the analysis of the literature in the field about adaptive learning and adaptive teaching. And there's a lot of literature, especially in engineering and informatics, about adaptive learning and adaptive learning systems, okay, based on artificial intelligence. For us, was much more challenging to find a common framework that could include both technical aspects of technical and digital aspects of adaptive learning and teaching with the pedagogical aspects of adaptive learning and teaching STEM education. And the other challenge was to find all these aspects, not only for STEM education, but also for the art education. We had to include also something that could be relevant for the art degree courses that were part of our proposal. With a systematic literature review and a desk analysis mapping also similar projects that were funded in our region, in this way, we found the Beready project led by this department and also the other project that could be similar. We co-created a framework for the adaptive teaching in STEM education. And this framework was not only based on the technical side, the technical aspects, but also with a pedagogical approach that was based on respect the difference of learning styles and learning educational needs of students. You know that the name of this intervention was about how to inclusive design processes, okay? Because the aspect of inclusion and accessibility was considered as particularly relevant for this project. This is the learning path that we have developed. This is a professional development program that could be, you can download it just scanning this QR code. It's open access and it has been uploaded in the website, and it has been also tested with a cohort of faculty and teaching assistants that were involved during the learning, teaching and training mobility that was carried out in Madrid in the month of April. So you can find it and you can give us your feedback and your comments about, you can help us validate this learning path that has been intended for teachers' professional development. Moreover, we have been developing 10 open educational resources that were in the form of video pills in a platform that have been uploaded in a platform that is called Erudire. And these 10 video pills regard each of these 10 modules, each of these 10 video pills regard several aspects of the adaptive teaching in STEM education. So I know that maybe our approach is pretty different from the ones that you have been listening this morning, or the approach that you will listen in the presentations that will follow, but we hope that you could find some inspirations for, well, at least you can provide us some feedback and insight about what we can improve about this. I want to show you, this is the QR code that you have access on our Erudire platform, and this is the kind of interactive video pills that we have produced so far. If you see, each video pills is considered interactive because you can interact with this, you can make some choices, and I just want to show you the demo. And you can have resources, you can have access to other resources through these video pills. As expected by this project, there will be the production of other two branch scenarios in which the learner can interact with a situations that is based on a problem-based learning. Also in this case, this problem-based scenario will deal with the topic of adaptive teaching in STEM education. Important thing is that for us, our target was not students. Our target were faculty and people with a teaching position in STEM, degree courses. So we did not work directly with the students, but we have been working and we still continue to work with faculty, teachers. Maybe we will extend the use of these open educational resources also with secondary school teachers, not only with the higher education teachers and faculty. And this is an example of the kind of a video appeal that has been produced thanks to this partnership among the network of people involved. Next, the toolkit. This is the third project result that we will develop in the next few months. It's still in progress, and it will include a methodological guide for inquiry-based science learning, a much more technological toolkit about which device you can use if you want to plan, design, and realize an e-lab. And finally, 3 case studies of how to design and realize an e-lab in different degree courses. What is the next steps? So for us, this is an example of how we try to validate what we have done so far with a group of experts. According to the project, we needed to finalize this toolkit and we need also to use this with, validate and test this with a larger group of students and faculty from STEM degree courses. And then we will have the final conference of the project in Siena in January 2024. Those are the kind of activities that we have done so far, like this multiplier event. Last but not least, we are caring about dissemination of our project through all the channels that we have. And we will need to prove the impact and the utility of what we have produced until now, extending the use of the learning path, the video appeals, and the toolkit with a group of 40-50 teachers in STEM degree courses, and in a second step, a group of 200 teachers and 400 students in STEM courses. So a lot of people. It's crazy the kind of impact that we should prove to the national agency. The final output of the project will be a manifesto for the adaptive teaching that we should produce in order to have a community of adaptive teachers for the STEM education. I'm going to finish. Do you have any questions? But maybe more than questions, input, suggestions, aspects that we could improve in those 2 projects. Any kind of feedback you have will be very much appreciated in order to implement and ameliorate the project result that we have done so far. Thank you. Oh, perfect in time, actually. For a person from education, being perfect in time, it's really strange, actually. I don't know if you have any questions or suggestions to improve, things that we needed to care about. I know that
you were like dead by all the content that we present you so fast, dead by PowerPoint, we say. I know this, and I know also that it looks pretty much abstract without any kind of empirical demo of what we have done so far. But if you have any feedback for us, this will be really appreciated. We really believe in the fact that we need to validate with a group of experts what we do. Thank you.
Alessandra, I have a general question regarding the learning that you are studying so but with all these new with all these tools that you know very well, I think now these new generative artificial intelligence, things like that. So how does it change?
That's the point that we are studying. Oh, please continue.
No, what I want to say is that because of course there are techniques for learning and also techniques to ensure that the student know theory or understand any kind of thing. But now, so the knowledge that this kind of students should have about the subject is a little bit different. So I can also accept that the student has, AI close to him, and together they can interact with me. So how can I be sure that they interiorize this consciousness of what they learn? Are you studying some technique to do this?
We are one of the topic that has been addressed with those materials was the kind of evaluation for the e-lab. Also in order to understand what kind of a formative assessment we should, formative assessment techniques we should adopt if we really meta-techniques and formative assessment more than summative assessment. So maybe it's better to work during the course with a lot of feedback and so on, instead of just have a summative assessment in the end of the course, in the end of any kind of degree course that we can have. But this aspect of how AI, is going to have an impact on students' learning and also on teacher teaching is one of the aspects that we are going to explore much more in depth. When we wrote this project, there wasn't it was 2 years ago, and we didn't expect that what happened this year in January 2023, and also the impact that it has had on our teaching and our professions as faculty. And so that's one of the, it was a kind of a serendipity for us to understand that we were carrying out a project of technologies for STEM teaching in such specific moment, and so we will deepen this aspect. We also hope to have other projects in which we can, for example, study exactly, maybe with the School of Engineering, how the use of AI will have effect on several different learning styles of students. That's the kind of interest that we will deep in the future.
Trying to understand to which extent we need to adapt, because for the design of a device, it is partially done by this digital world, and partially by us, it's still not clear.
Yeah. So I think that this will be our interest in the future. What I want to stress with the students is that I come from educational side, okay? I come from pedagogical studies, educational side, but there won't be any other. The education side in the future should face we cannot work anymore by ourselves. We really needed to cooperate together because, for example, the educational side knows that cannot ignore the technology anymore. We cannot anymore speak about teaching and learning without considering with the devices that we have, and how this interaction is not, we cannot separate ourselves from this interaction.
Thank you.
Okay, so if there are no more questions, we thank again. We move to the next speaker, that is Silvio Vert, and Silvio is associate professor at Politecnica University of Timisoara, and he will talk about augmented reality. This is one of the new tools that we were mentioning today. Okay, so Silvio, you can share your screen. Let me.
Hello to all. Thank you for your invitation. I will try to share the screen. Let's see if it works correctly. Just a moment. Is it okay? Can you see it? Can you hear me well?
Yes, great.
Yes, okay. I'm not able to see you anymore, but please let me know by voice if something is that needs my attention. Thank you very much. I'm coming from the Politecnica University of Timisoara, one of the biggest cities in the western part of Romania. This year we are European Capital of Culture, so we kindly invite you to come and visit us until the end of the year, because we have a lot of events and interesting places to see. I'm part of the team of the AugmentedWearEDU project, which I will mention towards the end of my presentation. And these are some things that we've done part of the project, or that we've done as part of our university since a few years now. Yeah, augmented reality is a very interesting technology. It's not that new anymore, but it's still very amazing. Actually, augmented reality works like this. It superimposes virtual information over a user's view of the surrounding environment in such a way that this information looks naturally part of the real environment. So it's not like in a virtual reality where you're completely disconnected from your real environment. This is why augmented reality is considered to be very appropriate for teaching, learning, and education. Augmented reality is used in many fields, of course, education, but you use it in tourism to find interesting places around you, in architecture and interior design. It seems that the slides are automatically going next. I'll have to do something to stop them. Or in healthcare, in manufacturing and maintenance, for instructions on site, and so on. This is my PhD studies from like a century ago, when I first created augmented reality application to show me interesting places around the city. And it was purely based on web technologies. But the hardware and software evolved a lot since then. What I'm going to talk first is about hardware for augmented reality. So what kind of equipment we can use to try this and create content for these technologies. First of all, smartphones, and they are very appropriate because devices that have everything inside them, so sensors, processors, displays, everything is already there, and it's really affordable. And most of us already have a powerful smartphone that we can use. To see what you can do with, for example, with augmented reality on smartphones, I can give you the example of the Spotlight Heritage Timisoara augmented reality application, which is a part of what we are doing for Timisoara 2023 European Capital of Culture. And I will show you a little how it works, but the idea is that you point the phone towards a building, and it recognizes the building and shows you how it looked like in the past. Let's look at a very short video that gives you an exemplification of this. The application was done in Unity for those of you that are aware of the software platforms. We will talk about them a little bit later, and with the SDK from Vuforia. It's available for anyone for free to download and try. And I'm saying this because other kind of augmented reality hardware are augmented reality glasses, similar to these glasses of Vuzix M4000, which are use some semi-transparent displays in front of your eyes to project virtual images, videos, animations onto your field of view. They have everything embedded inside them, like sensors, GPS, accelerometers, and so on. But they usually will be connected to a smartphone that you keep in your pocket for additional computational power and battery. What you can do today, they are mainly used in the industry for step-by-step instructions for operating a machine, for example, for engineers, but also for some contextually relevant information and interactive experiences. I also want to show you and talk about mixed reality glasses. So theoretically, mixed reality is something else than augmented and virtual reality, and together they form extended reality. But I want to mention here mixed reality because they are really close to what augmented reality means. These are wearable devices that combine augmented and virtual reality, and they understand the environment around the users. The displays are semi-transparent, and they project virtual information around the users, which are anchored in the environment, and users can interact with the virtual information with their hands. Let's see an example here. So this is from Microsoft HoloLens website. On the left, but on the right, the next speaker, Thomas, will be able to identify him playing with the Oculus Quest when we were visiting Kaunas. So actually what we've done is build an application for Timișoara 2023, European Capital of Culture, in which you can use your hands to manipulate various objects from our history museum, Banat Museum, to be able to understand and find some more information about various artifacts from the history of the city. So basically here you are in a room in a university, but when you put your glasses, the mixed reality glasses on, it recognizes the environment. You see it a bit grayed out, and you have some objects scattered around the environment. And you don't need controllers, it's just with your hands. You pick these objects, you can zoom in, zoom out, manipulate them. You put them in some kind of box, and it gives you some more information about them. It's constructed in like a game somehow. This was built by an international team of students as part of our project, as part of an international contest of Spotlight Heritage Timișoara, which we are running again this year, and inviting you to maybe apply and join to build some more application using this hardware and software. So where I want to go here with the moral of the presentation of the hardware is that we need to, we want to build some augmented reality applications, mainly for education, talking here. And we have to choose, we build for smartphones that we all have in our pockets, or do we build them for more complex software, that is more complex hardware, that is augmented reality glasses or mixed reality glasses. The advantages of the smartphone is that it's a device with all-in-one device, having everything there, very available, portable, and it all has a vast app ecosystem, so you can download a lot of applications and install them. So a smartphone would be a very appropriate for reaching a lot of people, a lot of students. But the disadvantages of building augmented reality applications, like the one recognizing the building on the street that you saw in the first slides, is that it has a small field of view. It's not that immersive, not that realistic as some of the augmented reality glasses can offer an experience. But the disadvantage of these glasses is, of course, they are very hard to afford. Their cost is around in the range of thousands of dollars still. We are waiting since a few years now for Apple to launch its own augmented reality glasses, and we will see. We think it will happen this year, and we will see what cost it will have and what it can do. But besides the hardware, we need to speak a little bit about the software that can be used. So I'm going to start the discussion from these SDKs, these software development kits, which are tools and libraries that developers of application use to quickly develop augmented reality applications. The most known ones are ARCore for Android smartphones and ARKit for Apple smartphones and tablets. And there are others like Vuforia, which encompass what I told you before, ARCore and ARKit, and add their own features. But you have to be very well skilled and have great coding skills to be able to use these. Another very popular and well-known platform is Unity. Actually, is a platform for game development, but it has some features specifically for augmented reality, and it encompasses all these SDKs that we've talked before. And we have used Unity to build the applications that I talked to you before, because we run them as complex applications on the augmented reality glasses. This is a screenshot from the Unity interface where we created the application for mixed reality glasses. And you can see here a temporary screenshot from an intermediate version of the application. But besides these applications that require very good coding skills, there are platforms these days that allow educators, teachers, and people without coding skills to create augmented reality applications. It's very important to know this, that they are not limited only to specialized engineers in that field. CoSpaces.edu is a platform that my colleague Thomas will, I understand, speak a lot more in the next presentation. But actually, it works in the browser. You don't have to download anything. It's very easy to add 3D models, import your 3D models, photos, and create animations, and so on. What I can tell you, what I want to tell you about this platform is that we created a lot of mini applications. We did, like for our technical museum in the university, we created applications that you can take virtual tours or augmented tours, and it recognizes various spots in the museum. We are running, my colleagues are running a very long project now together with students from Boston University in the US, and they are communicating over the ocean each year, generations of students, to create, as part of the TalkTech project, mini augmented reality applications and a virtual reality application, mainly on culture, arts, and technology. And they are doing it in the CoSpaces platform, students from first year. So it's very easy to use also for students and for teachers. And we've used this platform also to create mini applications with teenagers as part of some non-profit and citizen science projects. Here in Timișoara at our university, we are doing a lot of events with general public. We believe very much in spreading the knowledge about the technology and letting everyone know what you can do with these technologies. Other platform similar in somehow to CoSpace is Eon Reality. They are very well developed and they offer a lot of features. And you can also create spectacular augmented reality applications using their platform only in the browser. I'm hearing a sound. I don't know from what computer it comes. If you are kind.
It's Thomas. Thomas, can you please mute? Thanks.
To mute it. So now I hear a lot of echo. I think Gionata, you also need to to mute yourself. Okay. So what is the moral of the story with the software for augmented reality? So we have software that you need coding skills for and software that you don't need coding skills. I'm focusing on no coding authoring tools for augmented reality because I think this is more interesting for you. They are very easy to learn. You just need a browser to be able to construct applications. They use some kind of programming logic, but mainly you can use the CodeBlocks language, which kids used to learn how to code, so it's very easy. And you can very rapidly prototype something and publish an application in virtual reality for your students. Doesn't matter the subject or what you are teaching, and you can collaborate with other educators as well. But of course, there are some disadvantages for this kind of augmented reality applications created with no coding tools. Because they might lack some they might not be that super performant or super immersive, like when you would build the application using the Unity platform, for example. So if you want to go for very complex applications that you want to run on virtual reality, augmented reality classes, you would need to orient yourself to platforms that need coding skills. I want to briefly remind you about the fact that we are European Capital of Culture this year, and as part of this event that is happening since a few years now, we have been building on developing a project called Spotlight Heritage Timișoara. We again have some sounds in the background. Kind enough to mute yourself. Okay, and a lot of the applications that we've built until now are part of this project that combines culture and technology for the city. I'm not going to let all the video because it's quite long, but just trying to entice you to take a look at the website that you see on the right side of the screen, and then consider if you want to come here, please contact us and we can give you a tour and show you a lot of these technologies and equipment that I've talked about today. I will end by talking a little bit about the AugmentedWearEDU project that I know Gionata and Filippo introduced in the morning. And you already found out that we are developing this project because we want students to be able to learn things as part of virtual laboratories when things like the COVID pandemic hits. And we are trying to find out and teach other educators how to use AR, VR, and haptics to do this, and how to teach it as immersive technologies at distance education. Some things that we've did until now is evaluated the competencies of educators in using this kind of technologies and integrating them all together for teaching. This is a part of the survey that we've run here in our university at the beginning of this year based on the digital competence framework for educators. And what we found is how well our educators are standing on each of these criteria. So teaching and learning with immersive technologies, selecting immersive resources, engaging professionally with all of this, mastering and assessing students. And we found out that educators want to be professionally engaged, want to learn, for example, so a very good score, but they lack some skills in teaching and learning, selecting these resources, in creating them, and most important, in assessing how much students learned after learning something that used these technologies. What do we want to do next? So what are the next steps for us? We've obtained some funds from the European Union for digitalization project of the university. We are constructing a VR dome, virtual reality dome, for collaboration with immersive technologies and teaching students in a very large immersive space. And a VR, virtual reality treadmill, for example, that allows you to run and move while using a VR application, and lots more. So I'm looking forward to what will come next in the following years. Thank you very much for your attention. You have here my contact details, and I'm open to any questions that you might have.
Thanks, Silvio. There's an applause from the audience. And after your presentation, I'm really looking forward to be in Timisoara next week. So it was a good promotion, let's say. And no, I wanted to ask, then if there are questions from the audience, I can come with the microphone, but I would like to ask something about your perception on the cost of technology for augmented reality, no? Because now, with the VR technology, we reached a cost that it's probably affordable for most of the people. Now we are in the order of 3,000-4,000 of euros. No? So it's 300-400 euros. So it's something doable. While I know that Apple will have his own platform, but for sure it will not be the cheapest, knowing Apple a bit. So do you think that there will be a kind of new generation of low-cost platforms, or you think that in the next 5 years, let's say, we more or less we will have this technology for 2,000 euros or more?
Very good question. No, unfortunately, the short answer is no. The technology is still not affordable. So what we can do, we can revert to using phones and tablets for augmented reality, and that is very affordable for the moment for most of us. But the downside is the immersivity. It lacks enough immersivity. Equipment for that is immersive is very costly. It's in the range of thousands of dollars, not hundreds of dollars, as you said in the case of virtual reality equipment. Apple gadget will be, I don't know, $1,000 to $1,000, something between, probably. We just have rumors. Google tried their luck with their Google glasses something like 10 years ago, and withdraw them from the market 2 times because they didn't cut up. It's not only a problem of cost and that technology is not already there. So in augmented reality, it's even harder than virtual reality, because in augmented reality, you also have to track the environment. So everything virtual information needs to sync with real surroundings and give you a very realistic impression. For example, why Google Glasses didn't have success, it's because people had a lot of privacy issues with them. So I know some articles from back then that there were places, restaurants in US who banned people using Google Glasses because you actually could film and register everything that was happening around you while wearing those glasses. So it's not only a matter of technology for the moment and cost, it's also a matter of how people perceive other people and maybe themselves using augmented reality equipment. So we'll see. It will be very interesting.
Yeah, this is really interesting, and of course, once you share the view, your view, then you have to take care also of people that maybe don't want to be online at that moment. Okay, thanks, Silvio. There are any questions from the audience? No, you're satisfied. Great. Okay, so thank again, Silvio. We will meet you soon. I'll meet you soon.
Thank you very much for the invitation. All the best. See you soon.
See you soon. Thanks. And I think we can switch to the next speaker. That is Thomas Blauskas, yes, from Kaunas University, more or less. Then Thomas, you will say your name correctly. He's from Kaunas University of Technology in Lithuania, and he will talk in the next 30 minutes about virtual reality. So Thomas, the stage is yours. You can share your screen.
Okay, so hello everyone. It's nice to be here, and today I prepared to talk about cost spaces. So if we talk about virtual reality and how to do the things, one thing that teachers are saying for us is that VR things are difficult. VR things are complex. And for example, we have no problems showing the tools like Unreal Engine or Unity to our students. They learn it, but when it comes, for example, to pupils and their teachers, they are thinking that virtual reality is kind of unreachable for them. So for a long time, I guess humanity lacked some tools to show that basically everyone could do something for virtual reality. And for that purpose, probably I want to introduce you or maybe discuss with you the CoSpaces environment. I will switch to that environment and you will see it here. So I guess there are not a lot of people, or at least IT people who teach IT things that do not know this environment. But anyway, I will introduce it, and maybe you will find one or another aspect of this interesting. So I think CoSpaces was one of the first environment that demonstrated that the virtual reality things, as well as augmented reality things, probably Silvio already told you about it, can be that easy. But let's start from beginning. So this is the page, the homepage of that environment.
Thomas, we are not seeing your slides if you are showing something.
Okay.
So I think you have to share the screen.
I will try to share the screen again. One moment. Okay. Well, let's do it once again. Okay.
Okay, now is upload.
Sorry for that. Okay, so I'm going back and basically I will try to demonstrate things and what we were doing with our pupils, teachers, and students. So this is the main page of this environment, and let's see how it is good or bad. So what do we have for this one? So basically it explains everything also in the first page. So we have augmented reality and virtual reality, two things that we can do easily. For those who want something more for augmented reality, there is this cube. So it's not like in this picture. Basically, it's cube from markers, and augmented reality augments these markers with our creations. And so we can, as the teachers, create the study material for our students. But the more interesting thing probably is to allow the students to create themselves and learn in that way. So what students can do, what can we create? So if there are available some panoramic picture, either made by yourself or by students, or maybe taken from some library, so students can create 360 tours. By the way, one interesting project which was made by the pupils of one school was called The History of My Street 360. And it was about shooting 360 panoramas and then making the story from it. Lots of stories because each pupil needed to do his own history story. What can do more? We can create some kind of exhibitions. We can create some kind of a museum and put there various creations, like in this case paintings or some 3D models. And we can create some games. So when I teach students programming, we are usually making a hidden object game and learn from that. And also you can do some storytelling. You don't need a lot of programming to tell some story that includes three-dimensional heroes. So it's there's a lot of things to do. What it offers also, it offers collaboration. So basically you can create alone worlds, or you can do it together with other students. And in this way, you can share your task. For example, some students can create the environment, and some students can do some programming. What also includes code spaces are the lesson plans. So basically, whatever kind of teacher you are, you most likely will find the resources that suits you. And in those plans, if you open it, you will download such kind of PDF. There is education level, so for which students it is dedicated, subject, format and duration, also learning goals and benefits. Some examples, but probably what's more important, a guide, a creation guide or step-by-step guide on how you approach teaching your students. And in the end, usually there is a link to the actual project or a project template that you can remix in CoSpaces language or copy and create the things yourself. So what's more, so usually there are pros and cons. So one thing to consider is a price. So there is a basic version, a free version, but from my experience, if you would like to do something more, for example, if you want to include additional programming languages, more models, and so on and so on, so free plan is not good enough. So basically, if you are going to use this kind of tool in your teaching or production of some material, you need to consider that you are gonna pay by pro version. And it's not so bad. For the teacher, it is $50 per year. And also, there is additional cost. It is for each student or each working place. It's not about students, it's about the seats. You pay €7. So, for example, if you have something like 20 students, so you will pay nearly $200 per year. So for institution, maybe it's not such a big price. So I wanted to tell this because this is an important factor to consider because, well, people sometimes try that basic, that free version, and they think that the tool is not good. But okay, I will connect to my account, and we will see various things. So how it's done, we have a gallery. You can find here various things that could be interesting for you. For example, if you teach your students about space or about solar system, you'd likely to find this interesting. If you'd like to have a 360 tour, you can consider this project. And there are many, many, many projects. And if you go to a project, you can run it. And if that project looks good for you, let's see. So you can click on Remix it, and that project will appear in your space. We have classes here also. So basically, you can create many classes. Usually, during some events, I create for event the class and invite the students or pupils or teachers to try it out. And why it is good is because you can provide the tasks for each class. When you come to your class, you can see your students and your students' work. And if your students need some assistance, for example, or if you need to assess your students' work, so you can just click, open your students' work, see it, and evaluate it. The next part is CoSpaces. So it is your place where you store your own projects, and you can share your projects by using as assignment for the students. So if I want to assign in my initial creation to complete for the students, so I need to write some instructions. And I can assign it to individual students or to the groups of students. So if I assign to the groups of students, so people together can have fun and do some things. Okay, so let's see what different students made. Okay, so yeah, I will go back. Maybe I will find okay. I will find some example to show what people are doing and how I approach teaching them basically programming in two modes. One mode is co-blocks. It's something similar to Scratch, where you put blocks in order to create the logic. And recently, CoSpaces introduced a new thing, and it is programming in Python. So we can run it. Let's see. So in order to have some storytelling, it is some kind of escape the museum. As actually here is located in the Museum of War. You can click on the girl. That girl tells you that you need to find some free items, and you look for those items. And if you find all the free items, then this girl lets you go through to another scene. But I'm not finding the last one, so I will stay here. So how do I approach this idea? So basically, initially, we don't have anything here. So I ask students to upload basically brand new or completely new scene and use panoramic picture for that. Now the students can do the creative work. So there is a big library of various models, and you can put these models and use basically these four simple tools: rotation, scaling, moving, in order to edit that 3D asset. And these assets were prepared in such a way that you can change the material of shirts, pants, skin, hair, eye, and others, and in such a way customize your character. Also, what you can do, you can select animation. Normally, there are a lot of animations assigned to the characters, reactions, postures, actions like dancing, having fun, and similar thing. And it's right away. Pupils like to play with camera and do some storytelling when two characters are meeting each other, and well, we are doing some talk and other things. So initially, what I do, okay, let's open another one. Let's open this one. Initially, I let people put their character, the one that will tell you that you need to find some hidden objects, and then do the simple editing of a 3D environment in order for them to learn the mechanics. So they do not need to think on how to scale, how to rotate these things. And my session is for this one is at least 3 hours. And during these 3 hours, we create the hidden object game. Now, how do we start? So usually the most scary part is coding, because people find it really easy to start with adding 3D models and, well, augmenting them, adding animations, modifications with colors and similar stuff. But when it comes to coding, so it is, well, normally scary for them. So what we do it step by step. So you can think about the first program that you write, and what you do with your first program is to tell hello world. So if you will find it interesting, and if you will try coding with spaces with Python or with CodeBlock, you need to know is that here in code you need to switch this button so you can do you can access that character in your code. And there are also given code, how do you access? So for example, this girl, I will tell it girl. It is an animated item, and you get that animated item. And now the next line will be girl.speech, and the speech is hello world. And basically this is the start, the important start. And when we run it and we see that the girl says to them, hello world, they kind of starting to accept the programming. And in such small steps, we are going further. So we access all objects. We define some logic For example, when girl speaks about the task and when she checks if you found all the objects. And initially we get a big program, for example, something like 100 or 150 lines of code. And we are refactoring it, make it smaller, smaller, and smaller. And in order to do that, in our case, for Python learning, we introduce various structures that we learn in Python. And people, they learn and they find it fun. We are trying to make their solar systems, try to view it with virtual reality glasses. Also, with augmented reality, it's interesting for them to find all those planets going around in their rooms. And there are also things that you could apply in your everyday life. Okay, so this one I made for my kid who is very shy. So he hesitates to talk to other children. So what I made this one for him. He needs in virtual reality to click on this girl and he needs to answer in his real voice. He also likes those huggies wuggies, these characters. So I downloaded them, his friends, and he used it. So he is only 6 years old, but he is trying to put those models, scale them, and see if he had a success. So I guess that kind of exploratory thing where are really interesting for children because they feel like they can do, and what we do, we can experience in virtual reality. So as regarding for our project, I will just show you some examples from the students we teach. One moment. And this year, I also gave some tasks for my student, and this is the result. And the task was to make something that would make people interested in dormitories. So the student from Spain, she made a game, a murder in dormitory. So this is the student, and she made a video. She made a lecture how to do it. And if you are interested how you can do it, how you can do a murder in dormitory, such a game or elsewhere. So you are free to use this resource and see it step by step. So probably that's it from my side. I hope I didn't take too much time.
No, you are perfectly in time. And thanks a lot for this presentation. And it's really, really interesting. And I have a couple of questions. Then if there are people also in the audience that want to ask. One is if you are thinking to make this content also accessible online, or if it's possible, so to have a kind of metaverse where people can join, because I think now all these environments are offline, right?
Yes. You have a very good point, and one of the cons of that platform is that it doesn't really integrate good with other learning environments. For example, if teacher would like to provide a task in Moodle or similar, so he couldn't integrate CoSpaces into Moodle. So it's one thing probably for, and also possibility for companies and for researchers to make such things possible. So these things I can share. I mean, those Python lectures, similar ones, easily, and video on how to create step by step. It is also available in our project website.
Okay. And then my next question is, so you mentioned that you can also acquire with panoramic cameras environments and then upload it in the contents, right? So, but is it easy to do also with smartphones, or you need some particular camera?
Well, it depends. So during that project I mentioned, we tried photo. So when you have panoramic head, you turn it and make something like 8 pictures and then stitch it and get the final image. So for the pupils, it was really interesting also to do such things. For the quicker result, we had those Samsung 360 cameras. And with smartphones, also, so we tried, but it's not as quick and easy as with that Samsung camera.
Yeah. No, okay. There are questions from the audience? No? Are you sleeping? No, you are. No, they are awake. They are awake. Okay, so let's thank again Thomas. And thanks a lot for being here virtually. And we will meet in person next week. And so now here we have physical coffee break. No, sorry. We have one presentation more. Okay. Bye, Thomas. You can stay if you want, or you can also follow in the streaming on YouTube. Thanks again. Bye.
Thank you. Bye.
So I miss one talk. I miss Professor Pessot. Please. I was yeah. Struggling for the coffee.
So put here, right?
Yes.
Metto qua, sì.
Sì.
Ok, è lui?
Devi cliccare, se no non parli. Ho scoperto questa cosa fondamentale. Quando sarai direttrice del dipartimento ci sarà questo mouse.
Ok, online vedono questo, giusto?
Okay. So I will be not so long as I'm just before the coffee break, but
yes. Oh, sorry. Ok, perché io ho lanciato. Allora, aspetta. Sì, giusto, ok, allora. Sì, giusto. Niente, grazie a te. Ok, giusto, no? Sì.
Okay, so good afternoon, everyone. I'm Elena Pessotte, and I'm a researcher in management engineering. So during my research journey, I tackled with this technology, so augmented and virtual reality from the viewpoint of organizations and companies adopting them. So I mainly deal with the organizational and managerial side of the technology. And the work that I'm presenting you today is the results of some projects I had the pleasure to work in. So there are the results from one Interreg project, which was about digital transformation in SMEs, and two projects more dedicated to augmented and virtual and also mixed reality, which were VAM realities. And now I'm working on this project, which is Beready, and that has a name that's kind of connected to the one of the projects that are today with this event, because it is about realizing virtual labs, also exploiting the functionalities of XR tools. So I don't know why the slide is almost cut, but I hope you can see it correctly. So basically, as I told you, no, I think the graphics are not the optimal ones, but okay. I don't know why everything's jumped, but okay, fine. So we started from the core question that why, since we have been, we have augmented and virtual reality solution, it has been already almost 30 years that are out there, but only now, only in these late years, businesses and organizations have started to better look at them and started to think about how to adopt them in their businesses. And firstly, there are, of course, these opportunities that are provided by the pervasiveness of the digital transformation that now is characterizing all kinds of businesses, from manufacturing to service businesses, and also the educational field. And as you can see, also most important consultancy companies as PwC, McKinsey, and so on are identifying augmented and virtual reality and also wearables. So also about haptics as the core technologies companies should keep on investing in. So this is because companies are trying to find solutions that help them to access, to collect, and to properly share data and mostly valuable information within their businesses and with their clients, with their customers, and with their suppliers. So they're trying to leverage these technologies to properly display information and also to collaborate at the best. And third, of course, we are experiencing also several advancements, both from the hardware and the software viewpoint in this kind of technologies. And I don't know why the graphics are like this. Okay, but you can still read the most important things. So now we are seeing that XR technologies are applied in several kind of businesses, also businesses that are different from one from each other. So we find now examples as the projects that are here about education, but also in healthcare. So we see physicians also doing operations thanks to this, simulating the operations thanks to these technologies. Also in tourism, we know there are several applications with apps and virtual environments about touristic places, which were also kind of exit strategy for many touristic organizations during the COVID pandemic. We have examples in constructions with the ability to have the whole construction design, the whole project in that is built, the virtual model is completely built before the physical model is actually realized. And then also in disaster management, in order to access places that were affected by disruptions and whatever, and several fields, several applications. And this is because also businesses are beginning to actually appreciate the core functionalities and the core advantages of these technologies, because they are quite convenient. I mean, we can find devices like headsets and all kind of software tools at prices that are also accessible by companies. They enhance this good interactivity. They allow to work in security, so to access and to have information that could not be accessed with the physical constraints, also in dangerous tasks. And they are also allowing to augmenting and expanding the customer's experiences, thanks to this kind of information we can actually include in our virtual or augmented reality tools. But there are also downsides. There are also barriers to the adoption, because still many applications are limited or are considering quite sophisticated or not very applicable by the business, and there is really a huge space of opportunity for the adoption in the business in the industry. And they also bring together challenges that can be found at multiple levels, because we have technological challenges from the how to actually collect and process data to be used at the most effective way in these tools, about also programming, modeling, but also how to properly use the data that we have in these tools to be tackled properly for sharing and managing the knowledge of the company. So how actually the data that we use there can be exploited to be effective in our business processes. They are organizational also, because mostly, as it is quite kind of common in digital transformation projects, is that there has to be a strong commitment by the top managers and also a willingness to invest in these technologies, because there is the risk, as it was, for example, in Italy, that we have the calendar plan with several vouchers and supports for investments in 4.0 technologies, that many companies just leverage the voucher and the financial support, and then they are not using the technology for an effective results and impact in their companies. And so what has to be considered when we drive the adoption toward these technologies have to include several practices and several directions for a strategic transformation, starting from knowing what are the solutions out there, what are the examples, what are the key providers of the technologies, and also the possible collaborations with the other actors of the innovation ecosystem. So there are universities like ours, research groups that are working on these technologies and then can collaborate with companies. But at the same time, these investments have to be done with a strategic viewpoint, because also if we are talking about single devices, single applications, single tools, it is important that these tools are integrated with other technologies that are present in the company, and avoiding a standalone implementation, because it can happen that one technology that is used in a specific area of the company can be useful also for the other areas. So exploit at the best also the scalability of these technologies. And finally, it is a matter also of understanding what is the implementation path. So where should we start and where should we aim, considering that adopting technologies is not only a matter of programming, it's not only a matter of having the technical knowledge, but also knowing that this is challenging the current practices in the company. So it is also about organizational impacts. And starting from these insights that concern all kind of industries. It is interesting. It was interesting for us, for me and the research group I worked with, to study the adoption of these technologies in the context of small and medium enterprises. Firstly, because they are, I mean, the most, the higher number of companies that are in Italy and even in Europe, and they represent a core reference for the competitiveness of the overall industry. And also because they can represent valuable solutions for SMEs, because SMEs base their strategy on flexibility, reactivity, and proximity to customers. So they can actually leverage at best the XR tools. But the downside is that usually when we introduce new technologies in SMEs, it's even more risky and more, let's say, difficult than big companies that can invest millions of euros in research, and even if they are not, I mean, exploiting at the best these technologies, they have the other several millions to be invested in other things. So usually SMEs, it is kind of rare that they have a dedicated R&D department that also tackle this kind of technological opportunities. But introducing the technologies as extended reality tools within the innovation process of companies can unleash several opportunities that we will see later in the presentation. So looking at how SMEs are actually adopting these technologies, we performed an online survey. We collected more than 250 responses, and we also did other interviews with these companies. And we asked them, what do you think? Do you think that this technology has potential for your company? And the answers were mainly, you see, 60% of companies said that augmented reality actually are the solutions that can be mostly exploited, because you see here it is used especially to displaying the digital information about the existing. Why virtual reality is more conceived, especially in the first stages of product life cycles, because you mainly deal with, a total virtual artifact. So still, when you are not still producing or realizing your physical artifacts. And we also asked them, are you aware of the potentialities of these technologies? And you can see that actually they argue that these technologies have some potential and can actually contribute to a value added of the company. But at the same time, what emerged from the survey is that when we asked them, are you using them? They said, almost 60% answer, we are not using it at the moment. So we are aware, we know the potentialities, we have maybe the knowledge and the awareness, but we are still not using them. And then we asked them, okay, but are you planning or maybe are you aiming to use them in the future? And you see that a great percentage is intending to adopt this XR in the future. We stretched our mind and we ask ourselves, so what are the reasons why they are not properly adopted, or what could be the factors that should be leveraged to be properly installed and then to properly drive innovation in companies thanks to this kind of technologies. And what is interesting is that looking into cases, so we went to interview some of these companies, and we noticed that the pioneers, so the ones that are aware and that are actually using these technologies in their innovation processes, are adopting them with different with a different vision. So some of them are adopting these technologies with a long-term strategic perspective. So looking at investment that has a sustainable outcome in the long term, while others are still in their pilot stages, so are adopting some tools only in a few or even in one project. So they are starting this adoption. And we interviewed, so here there are some Italian cases are reported. The Italian cases, we had the chance to interview different companies from different industries, both manufacturing and services. And what emerged, let's see if the graphics work, okay. What emerged is that companies are using these tools with different outcomes. So some of them are integrating AR or VR in their products, and they are mostly finding as sources of knowledge the collaboration with universities and research centers. So since they are mainly integrating these technologies in the products, they are mainly focusing on the prototyping and testing phases. And here, they are also leveraging on, let's say, internal context to stimulate new ideas about these products. They are mostly leveraging on the training in order to understand what are the potentialities of these, the functionalities of these technologies. And you see some extracts from the interviews that they always try to be on point, to always monitor the trends of the market to understand if these new products can then bring to new business opportunities. Some of them are using these technologies to actually improve their services. So, for example, it was the case of a company from the construction industry. So they are using VR tools in order to have the overall project to be presented to the customer, and so the customer can have already a hint of what will be the final output before it is actually realized. And you can easily realize that it is useful to have some changes made already in the virtual model before having them implemented in the physical one. It is a matter also of cost, because of course, if there are big changes, it is different to implement them in the project or in the physical asset. And in general, customers are also satisfied. They value this augmented service. Also, they're available also to pay more to have it as a service. And here, the important knowledge innovation sources were especially customers that were more innovative, because one of the main barriers for companies, and especially SMEs, is that it happened very often that the market is not ready to have this solution. So they are not appreciate this kind of solutions. Other companies use these tools within their processes internally, so usually to solve specific problems in specific processes. And here it was fundamental, you see here as a source of innovation, it is called the innovation champions within. So employees that are more proactive, that are more, let's say, open to new solutions, to introduce new solutions in the company, and they can act as, let's say, influencer within the company, and make also the employees that show more resistance to new technologies to actually adopt them and use them in their daily tasks. And here they worked, main issues was about actually integrating these technologies with their information systems that are there, because you have data from the process that have to be included in the virtual environment, and at the same time they need to be able to share it with their internal systems. So here was the case, for example, of a company doing welding operations, so very risky operations, and the operators could be both trained, so it was for training purposes, but also to perform some tasks that could not be performed because you can't really access the machineries, because the temperature is, of course, too high for humans. And finally, very few cases were able to actually exploit these technologies to really change their business. So an innovation at a very strategic level. And they really was able to integrate these technologies as part of the offering. It was the case of a company selling machineries, and they included the data collected through the machineries sold to their customer and accessed through these kind of tools in order to provide more effective services, more effective assistance to the robots sold to the company. And the manager here interviewed was kind of positive, kind of forward-looking. So he said he imagined that in the future, these so interactive technologies will be kind of becoming the standard, as also smartphones became for us. So they are really a forward-looking company. So this kind of innovation was achieved in very few cases. And so to conclude here, so we observed through this project, this data that we were able to collect, and also this interview that we made with companies, that still these solutions are not systematically adopted in the industry. And essential drivers are the openness, so leveraging of different sources of knowledge, such as universities, but also innovation intermediaries and enterprises associations. And of course, being willing to actually perform innovation. Secondly, what emerged is that it's not only about, technical developments, but mostly it is an organizational issue, spreading the adoption of this technology. So there is what is needed to actually have a jump, to have a very widespread adoption in industry is working on these kind of variables. So increasing the awareness of the application of what are the core implications and what are the core impacts of extended reality tools in companies. And lastly, what we saw in the business side, we are also experiences in the educational side, because if you think about, actually, we as universities can be also assumed as an organization. So we have professors delivering teaching, the product is teaching, and the customer is kind of the students. So these XR tools can be considered from their adoption viewpoint also in university, or in general in organization delivering didactics and research. And also here we noticed that in the design of, so the last project that I mentioned, it is about the design of virtual labs. So we noticed that also here you also need to work on the organizational variables. So having the knowledge and the alignment with the overall strategy, that is, the core didactic plan, and also leveraging on the innovation that is made from the research groups to be actually integrated within the educational programs. And about this kind of applications in virtual labs is what is telling you later Vladimir, that is also a colleague in the project Beready, that he will also present later. And to conclude, what you are experiences from the educational viewpoint is also present in organizations, and organizations are adopting XR in this way that I presented you. So, okay, I conclude here. I think I'm in right time. So thanks for your attention. If you have any question, I'm available to answer, of course.
Because the other one is not working.
Okay.
Maybe this one is, yeah.
Okay.
This one is working. So is there any question? You get to mute this. No, I have actually one question that it was my experience with people in the company. So it is exactly, I mean, my small experience is exactly in line with the graphics you show. With the trend is that. So people that are interested, there are people interested, especially, I mean, in the automation part. They are interested in having VR solutions to explain the machine. So especially for the control schemes and all the control panel, they said that usually they have to send the people when they deliver the machine. They would like to send actually the HoloLens or whatever, and to have the augmented reality explaining where are the parts and whatever. But then they have this dream, but nobody. And my impression is that what is missing is companies proposing a tailored solution for this small company. So I think that if there are, I don't know, private or small company that start to build this kind of solutions, because they probably don't know, so they are scared to start this internally because it seems too much complicated to probably to afford with their own R&D department. So they are scared to start something very new in VR area that seems far from what they are doing. And so probably, I mean, my impression is that is missing companies proposing this kind of solution. But are you aware if there are actually companies, maybe in Milan or so, that are already proposing ER solution to other companies?
Actually, okay. Actually, what we experience is that, first of all, it's not only about having customized solutions for the small and medium enterprises, but firstly is to understand what the current solutions can actually deliver and how can be actually integrated to their business processes in order to unleash this value. And during, for example, the project, we organize a challenge, a competition of solutions more cut for small and medium enterprises, and you're right. And it was the main proposal arrived from universities and research center teams. So I think that this kind of development is still at the basic research, or I mean the research done in universities, but still on this kind of tools, it is less. Less developed the market of tools that are customized for companies. What they can do, in any case, is something that also is stimulated also for other kind of 4.0 technologies, is to collaborate and to rely on the innovation ecosystem in order to have different providers, maybe to be to integrate different kind of solutions and to be delivered to different companies in the same ecosystem, and to reach economies of scales in this sense. So this is what we observed that was mostly working. But you are right. I mean, the cases I presented here are companies that actually buy the devices and leverage for example, software consultancy companies to have them personalized, or the more innovative ones, they build a team internally to have their own software built to actually exploit them. So still that there is work to be done, and in this kind of tools.
Yeah, this could be, a stimuli for students here that, ideas for new companies. There could be companies developing ER solution. But I think that one similar thing was on 3D printing, and there was the pioneering companies were the big one that were presenting. I remember like 10 years ago, those that presented also 3D model, 3D printed was something super effective. Now it's, I mean, any of the research R&D office, they have a 3D printer now. So probably the same path will be for this VR solution.
Yeah, especially because it's kind of one of the most, advanced, most expected trend for the next year. So of course, something has to be done also at the industry level on this point.
Okay, are there any questions from the audience? The audience is not very familiar.
Waiting for the coffee.
Yeah, maybe we are all waiting for the coffee. So thank you again.
Okay. Thank you for having me.
So we resume in half an hour with Professor Pratikizzo at 5. So see you later. Muta il tuo microfono.
Now can you hear us?
Yes.
Okay, so if for people who are missing the first part, what I just said is that we developed a wearable technology that is completely mechatronics. So inside there are motors that deform the skin, there are piezoelectric motors that vibrate the skin, and there is also a Peltier cell for the temperature. So you can perceive here both skin indentation, vibration, and temperature. And this is a device that, from a patent that we made in our laboratory, now became a startup. And Giovanni and Guido, who were PhD like you, now are running this company that is really, really successful. Now, the kind of application, for example, here it was Guido and me and Giovanni at Las Vegas showing our device in, that was actually the prototype at the beginning, just showing how this device can interact with the virtual environment. Now, there are many other applications like this one. You can have, again, the people developing the digital content. For example, here there is a chemical lab, and the people developing the helmet, who are not us, and people developing the interface for Haptics. So these are the engineers, mechatronic engineers, and maybe even people dealing with the display, visual display here, and people doing the contents. Really, three different community. Okay. For example, this application, the startup is collaborating with the content developer that are working on the digital environment. Well, it's another application, another subject that I would like to talk about. This is really new, is something related to this tactile technology, not exactly for augmented reality, but for a distant reality, okay? So you do some technology because you want to be present somewhere else. So neither virtual nor augmented, but remote reality, which is a sort of communication. So I want to touch something somewhere else. The same technology can be used also for the same technology can be used for VR, for AR, and for remote reality that we call RR. Tommaso, RR, remote reality. Huh? It's nice. It's nice. Okay. So basically, there are these three technologies: audio, video, and tactile communication to have more present stuff. Also here, we started to have this development since in 2010, where you can see you can use the technology to touch somewhere and replicate the touch somewhere else. So you can really touch an object here in Siena and replicate this tactile interaction somewhere else. Okay, for example, in I don't know, in Rome. This is very important because you can you have to add to the technology that I just showed you to replicate on the finger the tactile interaction. You have also to have technology to record something, because you have to digitalize the touch and you have to transmit. I touch something here and I can let you feel what I'm touching on this side. This is actually very important. Digitalization of touch and having a sort of microphone for the touch and a sort of a speaker for the touch. Good. This is, of course, has several applications. This is the last one that we are trying to target, and there is Michele here, there, that is simulating telepalpation in. Okay, so the idea is that this is the patient. This patient has to be visited from remote, from the doctor who is somewhere else, and he wants to let the doctor feel the consistency of the lymph node, for example, if it is stiff or if it is more, compliant. So he is touching, self-touching the lymph node with this tactile technology on the finger, and is replicating back on the finger of the doctor. So the doctor is really perceiving what's going on there. Okay, so this is a good application for telepalpation. You can think about many other applications. This is Guido, who's not here, is the co-founder with Giovanni and me of this startup, we can simulate here like this guy is touching different textile and is replicating this textile to a person who is somewhere else. And this is something that you really know. Of course, if you want to make a taxonomy of the touch, so touch is used mainly for three things, okay? So it's used for discrimination of object, like if you want to touch an object, you want to recognize a tumor, okay, from normal tissue, or I want to touch, I don't know, a cream, and I feel that it's a cream, or I want to touch the bread, and I feel the mechanical property of the object. So you want to discriminate these kind of objects. First application of touch. Second application of touch is not in order of importance, but is for sure the emotions. So if you want to shake hands, if you want to record an experience when you have to, wait for a baby or your grandparent, you can record all the interaction with the hands of your parents or many other things that you can think about. This is, for example, an application where she's touching a baby. That is actually my daughter many years ago. And Stefania is recording the tactile interaction with my daughter while taking also with the microphone and camera the experience. So in this experience is video, audio, and tactile digitalized. So you can record and you can play back after 10 years, or you can just transmit remotely what she's perceiving, okay? For example, this is another application. We used a lot, in particular, the startup used this application for COVID in Milano, where there is someone in the hospital and alone, cannot interact tactile with no one else. There is a pathology that is called skin anger. So people really need the tactile interaction when they were at the hospital. So the idea was that the son of the father or the mother, I can wear these things on my finger. I can go in a sort of self-tactile interaction. I can touch myself. And my father can perceive exactly this kind of interaction, which is the way I squeeze the arm, the way I caress the arm for vibration, and even the temperature, okay? So that's an important sense of presence. You know why this is very important? Because, for example, I can talk with Alberto, we can talk each other now from distance, okay? Or with Alessandra there, but there is no perception that I am there. If I touch you, if I shake the hand to you, either to Alberto or to Alessandra, then you have the feeling that I'm there because I entered your peripersonal space, right? So the tactile interaction, you really have the sensation that the subject is here, very close to you, okay? So this is very, very important. Then, of course, you can use the tactile interaction for guidance, the third application. So object discrimination, emotions, also guidance. If I am blind, but also if I am not blind, if I am blind, there is someone guiding me through tactile interaction, okay? So the volunteer is going to move to guide me somewhere because of this tactile interaction. While he's not talking with me, it's not me, this is Massimo Vita, the president of the Union of Blind People in Siena, because blind people don't want anything through the hearing because they want to listen the city, okay? They don't want to have anything there. So also here we had some idea. The idea, there are two main approaches for this blind guy. One is to transform the blind guy in a sort of Tesla. Like they put radar, they put cameras, they put in the stick, they put a lot of technology. It's like an autonomous car without the engine. So they move and they are guided autonomously. Or we didn't like to do the same thing that people were doing. We took another possible road of research to help this kind of guy that was mainly to help the volunteer, not blind. So if a volunteer should help me blind in Milano, he has to reach the station, 1 hour to reach the station, then help me, I don't know, another hour to go somewhere else, and then go back to home. It means like 4 or 5 hours for the volunteer with 1 hour of volunteering for me. So the idea was mainly to keep this guy at home, and if you want to keep this guy at home, he has to see what he's seeing, so you need a camera on the body of the blind, streaming what's going on to the volunteer, but you need the hands of the volunteer on the blind to steer. So this is the idea of tactile angel. Tactile angel, this is at home, the volunteer, the camera is streaming everything, and the hands of the human are here, okay? So, and then you can really steer the subject. I don't know if this is an application that you can, I will skip that application. Okay, another application is on with Parkinson. So we can, these are not, is not good because the video is going up and down. But I want to show you that this guy is having tactile interaction at the anklet. This kind of Parkinson, sometimes they have the phenomenon of freezing. So they really, it's like if the shoes, if the foot is glued to the road, they really don't move. This is the reason why they fall down, because they want to move, but the foot is there. Not because the muscle is not working, but because the motor control is not working very well. By using the stimulation at the leg, through the vibrations, we can remove this guy from freezing. Look, this guy here is working normally. Now he's freezing, so he's not moving anymore when he arrives here. This is very fluent. Now he's stopping here. He's stopping because of the freezing. Because of freezing, he's stopping here. Oh no, this was the, it's a long story. It's the second round. It's the second, because I had to cut at the right time since I moved from, I think it's now. Now it's freezing. Now it's freezing. It's not moving because of the freezing. See here. Now the doctor is activating our anklets and it starts to move. Okay. So basically, a single vibration at the foot, at the anklet, let him move in some way. So there are all these kind of guidance application for blind. Then we were talking about another application. Now I'm going to present two new applications, even partially from the lab. There are people that know it, but not very well, so I want to catch your attention here, because they are very important also for people from the lab. I mean, are new, not important. One is to try to extend the human collaboration and the human-robot collaboration to another level. That is the dance, okay? Why the dance? Why the dance? This is a good question. Giuseppe is there. Giuseppe Saviano is working a lot on this subject. So the main idea here is that actually we were mainly inspired by this video. Have a look to this video.
I apologize. I have a question now because I was enthusiastic.
So if you look to this technology was quite cheap when it was in the lab. Then it went to 10 per after, 10 times the cost of the lab because of everything that is around. Now, if you go to the medical area, so you have to add to these 10 times also the cost of the certification, because this is not a medical device. When you have a medical device, you have to certify it, and you need at least 1 million per device. That is, I mean, if you want to spread with one device, it's 1 million plus the previous cost. If you spread if you divide the cost over 1,000, it's much less. Sure. Some other question? Manish, you have always question. Now you have one question. No, you should have.
I am thinking about some ideas how actually I'm from mechanical background, so I was thinking is it necessary that we only use the pressure? Why not pressure waves?
Pressure?
Waves.
Waves.
Yes, like sound waves. We have pressure waves.
Sure.
And equipment waves.
For example, if you want to do internal organ, you can use pressure waves to vibrate the organ and try to stimulate at the same time.
Yes.
Good point. Now there is a demo.
No, there is the last book.
Okay, sorry. Switch off.
Okay, so let's thank again Domenico Pratichizzo. And we have now the last talk of the day, that is Vladimir Katz from Tallinn University of Technology. Hi, Vladimir. Actually, it's the first time that we met, but Vladimir is participating in a project with Professor Pessot, so we had the opportunity to know him, and we are looking forward for your presentation.
Yes, thank you. Do you hear me well?
Yes.
Shall I scream more or louder? Okay. So I think I have a last talk, yes?
Yes.
It's a day. So I have only 95 slides. I think it's all right. So no worries.
Take your time.
I will take my time. Thank you. But wait a second, please. I will just share my screen. And I guess it all works, yes. Okay. Okay. Let me, 1 second. Hello, everyone. My name is Vladimir Kutz. I am from Tallinn University of Technology, and I'm senior researcher and head of industrial VR and AR lab here. So my background is mechanical engineering, industrial engineering. So I'm from manufacturing background mainly. And currently, actually, I am residing in Ireland, in University of Limerick, where I go back in a few months back to Estonia. So what I will speak about, I told I have 94 slides. A bit lied to you, sorry, a bit less. I hope you're not disappointed not having so many slides in the end, but let's see. So what we speak about today. We'll speak about virtual labs, yes, from education to research. I'm a researcher, so I will tell you mainly about research, what we do in our group. However, I want to tell how the education and research can be connected from each other, and how we use the same concept and how we use the same, let's tell, model or frame. I have some of things what I will mention here, as Professor Pisot already mentioned, about Project VIRLADE, about Virtual Labs for Digital Engineering Education, which I will mention a few slides about it, which we do in collaboration with South University of Denmark and Italian National Research Council, or CNR. And so, first of all, I will just tell you a bit about what we do in VR and AR field in Estonia. We have few companies who are doing something educational in Estonia, and from VR in virtual reality mainly. And I'm also a board member of Virtual Reality Association of Estonia, so I have some videos to show, so I will do it. Use my chance, and then I will tell you a bit digital engineering education project, and then about the laboratory and what we do there, and some industrial use cases. I mean, industrial use cases in the lab environment mainly, but still, and just tell you briefly where it can be used. But from the previous speeches, actually, I heard already something what I will also tell. So I also skipped my slides about what is VR and AR. So I believe it's after this long day, you already have this knowledge for sure, and if not before. So first of all, there's one Estonian company called FutuClass. We here speak not about education inside the higher educational institutions, but in the schools. So, for example, this company is aimed to do STEM education in the school level and teach kids of different STEM domains inside the VR, like chemistry, physics, electronics, mathematics, about atom structure, about some reaction balancing, hydrogen, oxygens, about molecules, about magnetism, heat, friction, and a lot of different applications they have there. Here is just a small example of chemistry reactions. So, for example, there's a task, create hydrogen, and students should do hydrogen and then sees, connects it together and sees how it works and if reaction is correct. And there's a lot of interaction, a lot of animations now. So I think this makes chemistry education, for example, much more engaging, and other STEM, and to raise interest and have it more interactive way. Then Estonian Rescue Board, the actually Academy of Rescuers, Policemen, and Border Guards, they are making their own applications from educational for popularization to wider public. So, for example, this application is for kids how to behave with open fire at home. And so basically what you can do at home, what you can do if it's a fire, where to call. So it's mainly used for exhibitions as well as popularization events. As well as next one is also used in schools. Wait a second, it's the same. In schools, Estonia have really a lot of forests. And we are covered by forest deeply, and this is about how to behave in forest if you're lost. Also, we have still, after World War II, a lot of not demolished bombs in the forest, which you can accidentally find. I saw at least two in my life, one on the beach and second in the forest. And you need to know what to do when you find one. And basically this one is also to eliminate these cases and to know what to do, how to call the police, how to tell your coordinates, and etc., etc. Then another one, last one, what I will mention is about making music from different instruments without video, different instruments, different nationalities, different historical instruments, and you can all combine together. For example, some Syrian drums instruments with a violin and etc. So how they will work together and see it. And yes, so I come from IVR Lab and Taltech, and we and virtual labs for digital education is a project what I will slightly present. So it was Erasmus project. As you see, it's almost finished. It's only 1 month left, and we are busy with it right now. But main idea of this project is to, create a framework and guidelines for development of virtual labs. And first of all, of course, outputs is to analyze the physical labs, then develop a courses and workshops, which will be connected inside the virtual labs and will be some kind of merge between physical and virtual worlds. And then at the end, we are proposing our own course, what we made between 2 institutions, actually 3. The one lecture is from Chinar, and then main students tested it in different workshops. We had 3 workshops in Denmark and Estonia, and then basically now we created a framework for guidelines how to create different virtual tools based on the experience of the lecturers and inputs of coders, of stakeholders, of students as well. It's very connected to feedback from students and as well as lecturers. So because we do it for students and also we do it for lecturers from point of view that it should ease them to educate it. And I will show you some video later a bit about it. One of the just one use case, which is actually between 2 different Erasmus projects together, and it's combination, nice combination. And we use all these technologies and like digital twins, synchronization networks, Internet of Things concepts. We hosted on GitHub, and we use XR for better immersion. However, we use also human avatars to enter our applications because not everyone have VR headsets, and also you want to have as much users as you want there. And also one important to mention is that good guidelines also include, let's say, topology and a set of rules how to integrate your own lab inside the application, make it virtual. So basically, by having a list of 3D models and functionality and sets and processes can be done quite in an easy and fast way and integrated together with us. But to example point of view, I will just put a pause a bit. So it starts actually with, everything we do here is aimed to be modular. So everything you would like to utilize in research and education. So all software we are creating, we are aimed to make open source. Part of our applications is actually frameworks for collaboration of robotics, for example, and this topic was spoken by previous speaker, and but we are from industrial robotics side more, and we aim, let's tell, to give it to more wider public so everyone can use it. And our aim is that we can have a models and connect it all together. And right now we have, for example, Danish and Estonian labs. We have connected. We have multiplayer there. We can go to each other labs and do something together. Of course, the server is running right now. It's not actively being used, but it's ready to be used. And one of use cases, for example, it was created with another Erasmus project called Prameco, and it's about gamification of making pneumatics and hydraulics course, which I was teaching for 5 years. That's the reason why we do this course exactly. However, not teaching it anymore, and the new lecturers actually using it quite actively. When, for example, it was developed during the COVID. The concept was created, but main idea is that we assemble everything in the game, and then we see video how it's being working. And also with electropneumatics part and electrohydraulics part, we actually control it online. So there is a webcam always watching on it, and there are a few benches, so you need to reserve a slot, and it's moving based on your schematic done and your circuit diagram done. So now let's speak a bit about research. And so it's our lab. We aim to, So our ultimate goal is connect all laboratory devices and physical with virtual environment. So we don't think digital twin is only simulation. We think we can interact with physical world from virtual world, and this is what we are intent to doing. But if we speak about classical digital twins and a digital copy of some real object, it's like let's speak about industrial digital twins, and it's about device level, equipment level, like robot level or CNC machine level, for example. Then it's process level, and then all system level. And so it's digital copy of it, and we actually can aggregate the physical data from sensors and feed it to the simulation, and then see if we make some layout change in the factory, how it will behave. XR is a good tool to go inside this world, but it's not mandatory tool. However, it makes it easier to understand and scale and about what changes did you do. And our main focus is what we are working a lot is a human-robot interaction, but we are creating mainly interfaces for the operation of industrial robots. And we use XR technologies for it, so VR and AR, and we intend to make everything modular. Because right now is actually a lot of different collaborative robots standards. And there is no one standard, and as much as no IEEE working group is creating a new standard now, and which should unify all of them together and as well have a simulation validation part aspect inside it. Because right now there's different type of human robot collaboration, and for example, this is also one because there is the same room. However, they work on different locations, let's say, for different tasks. Here they're already in the same line, however, they still do the different task because it's coming in the sequence. Here they also do the different task, but they already work more closer to each other in the collaboration. Here they seamlessly adapt to each other, sync each other, and as I saw from nice previous video with dance use case, and actually they can synchronize with each other. But what we do in our labs, so first aim, of course, but there was already on some video, we need to digitalize it. So we have it fully recreated, actually 2 floors of our campus. Of our mechanical industrial engineering campus, not full university, of course, yet, but we have 2 floors with classrooms and with devices, equipment, where we do our experiments. And why I mentioned about human-robot interaction, about modular matter, because what we do, we try to understand which is the most comfortable level to program the industrial robot. Is it this, or it's offline programming behind the computer? Or maybe we can control it from VR, being on the other side of the world, and just manipulate the robot. All these videos here shown are actually in 6 years time frame. This one is done actually 5 years ago, but this was already newer. Or we can actually make a full routines, full patch plannings ways. We can access. Actually, we have machine learning agents behind the concept. So basically, we can teach in simulation how to sort or pick up or work with some objects, and then we transfer this knowledge to the machines. And this actually control element of it, it's open source, and we have Docker containers of it on the Linux side, and you can build any interface you want on top of it. Actually, it's mobile app, is it VR, AR, what you want. We combined it all together, made some of our code and put it together. And also you can see in a full scale if it's going to collide with something or not. But let me go a bit further. Oh, I will not, because it will jump to the beginning of the video. Yeah, so it's a real-time controller, it's programming, or it's combining, or it's mobile app. You can just manipulate the machine. Moving is just like one axis is not so interesting maybe, but making a full planning of the routine is more. Or you can do it together. Why do you need to do it alone? And so my main research topic is to combine different interfaces and to evaluate which is better for people, let's tell, to program machine from hazardous environments. But sometimes you can be just remotely and do it together. but it's almost finished. Because working together is more fun. And yeah, we also use digitalization tools to control real-time monitoring of planning systems, to have some guidelines and educate new workers what they should do in a sequence. For example, it's a metal 3D printer, and a new worker need to make a sequence of jobs before they can really launch this machine. And it's just a simple application, actually, where you can just jump from previous to next task and see what you need to do before you can really launch it. Or you can use it in assembly. Actually, this one have what AR mode and just 3D models animations. And this was done, actually, this is being used in one of the companies in Estonia, and they had the learning. They had all of this in PDF, and learning curve of new operators was 1 hour, 17 minutes, I think, and they reduced this for 30 minutes. Tested it, 45 minutes was for new worker, a new learning curve instead of 1 hour 15. Okay, experienced user does it in 30 minutes. It's regular time for worker who works there for some time already, but just to assist and guide in animations. So we have prototype framework for the educational environments and measurements of human-robot interaction metrics and VR environments with different free laboratories actually inside it. As I mentioned before, Denmark and Estonia. Actually, we have also one American laboratory also connected to us. And then we work a lot on connectivity methods optimization, on interfaces creation, and integration of different new machines. As right now we can work with 4 different types of brand robots, and we look for more. And we do something of it also as machine vision elements of it in rehabilitation concepts and smart workplace I was showing to you already. So we are always looking for collaborations and adding a new use cases into our framework. So if any of you have any ideas, if any of you would like to do something nice and cool together, there's my email address, our website, which is not updated for 1 year already. I need to update it, but there's still some nice videos on it, what we do. And nice to be here. Thank you. And I hope it was not a long night, 4 slides already.
Thanks a lot, Vladimir. Actually, there are a lot of interesting things because we are here. In our research group, we are working in robotics and both in human-robot collaboration and in rehab and also in Haptics. So I think that we have many things that can fit together. So just for us, we can schedule a more in-depth call to discuss. We can present some more activities of the group, and then we can discuss. For sure, I see many. The first thing that comes to my mind is that all the visual interface that you have could be tested with some haptic feedback, because we are doing something in that sense, but let's say simple visual interface, sometimes even without any visual interface. So we only have wearable rings with buttons, and we activate motion of robots, or for instance, we can control the closure of a gripper, something like this, with any visual guideline, let's say. So I think that the combining the two things could be really interesting. I don't know if you have any previous experience in adding some haptic feedback to the ER.
Yeah, we used only we bought once Manus VR gloves and tried them. However, we didn't really do anything for some years in that field, and we actually will be interested to do it and to compare with methods. And we are also very interested in some EEG devices but it's already another topic. So it's additional. But right now we are controlling mainly with gestures, what we aim to do.
Okay.
So we do a lot of gesture recognitions. However, haptics can really help to like make the gripper like a strength adjustments, as well as some more sophisticated, let's tell, movements to capture for giving the signals. There is one collaborator in Ireland where I am. She works on haptic gloves, and it could be maybe interesting to combine and work and do something together. I mean, we will be happy to add haptics into our framework and to do some experiments with it, and to compare maybe gesture recognition with haptics, how users will take it.
Okay, so I'll send an email to you, and we can
perfect. Let's do it.
arrange for another meeting. So now we thank you again for being here today. And hopefully you will be here in person soon, if we can collaborate. And
I will be happy to. It's just
okay. So this talk ends the part of the day with talks, actually, and so now we have this experimental session, let's say, where we have demos. But while we wait for a demo, because I mean it's something that we have to wear with, so only one person can do at a time. We can grab a beer outside and wait with a beer in our hands. That is a nicer way to wait. Huh? So thanks a lot to all the people that attended online and also here in person. I think it was, to me at least, it was really interesting to see all the different aspects, no? From high school to university education and to also company. So it was a very long journey with a lot of nice talk. So thanks for being here. And let's have a beer.
Now I need to grab one also from the fridge, yes, to be like with you together.
Yeah, the beer it's a nice add-on to be in presence.
Yeah, next time.
Yeah, next time. Bye. Thanks again, Vladimir.
Bye. See you.
Bye. Termina la chiamata per tutti.